We are live from the Anti-Gravity Lab. I am the alien scientist, and you are in for a show tonight because we're going to be arguing about how anti-gravity works, or how it doesn't work. And as usual in science, experiment will be the arbitrator of competing hypotheses. And we are going to figure out, hopefully, one way or another, what doesn't work. Obviously, we're going to figure out what doesn't work, but hopefully we'll figure out what something that does work eventually. So Mark seems to think that we're going to figure out anti-gravity. He seems to think that I think he... Why don't you just get in front of the camera and explain to us what you think about anti-gravity?
About anti-gravity?
Yeah.
I think the term anti-gravity in itself is really a misnomer. We're really just trying to figure out how flying saucers operate, and I think they definitely do operate, and there's definitely some way of doing it, and we're trying every single method that we've heard of that can possibly create these sort of effects. I'm particularly excited about the dynamic nuclear orientation setup, which would basically negate the inertial mass of a craft.
Please look through that.
But what we're doing today is not dynamic nuclear orientation. It's more about just creating small amounts of thrust, which are needed even with dynamic nuclear orientation, because even if you have the craft almost weightless, you still need some way of thrusting around and moving in space. You could technically do that with rockets, but you don't want rockets. We want to move with other electromagnetic forces, and that's what we are trying today. And dynamic nuclear orientation, it's a much more difficult experiment. It's probably going to be coming up in the next week or so, if we get everything going correctly. But that's pretty much what we're talking about. Okay, the guy speaking now needs to turn up the mic. Oh yeah, there's only one microphone, so I guess it's all the way at the max. Can't hear anything he's saying.
What channel is he on? Let's get him up.
I'm trying.
Can you hear it?
I shut all the other ones off. It was working, and now it's not. Keep going.
Testing 1, 2.
Oh, you got to hold it right in front of your mouth when you're talking.
Oh, okay.
Not right there, not there. A little bit further away.
Oh, we got to change the setup then. Okay, so basically what I was saying was that I think anti-gravity is a bit of a misnomer.
Jesus.
Is everything okay?
It's
fine
way
now.
too loud. You hold it like right here.
Is this good?
Yeah, right there.
Okay, so everyone should know it's about a fist away. Yeah, we're running into a couple technical problems. We're missing our chief technician, and Jeremy had to put on 2 hats tonight in order to get this stream going. So shout out to Jeremy for that. Anti-gravity, back to the question, we are trying all different things that can explain how flying saucers operate. And most of the experiments we're going to be trying tonight are related to thrust. There might be some element of warp drive in it, or ionic wind. We're trying to make sure there is no ionic wind, of course. But they're related to thrust that can move a craft around with a couple kilos of thrust, and then with dynamic nuclear orientation, you can negate the inertial mass of the craft, making it almost weightless, and that would explain how the flying saucers operate, how they do 90-degree turns at 10,000 miles an hour, and so on. And without further ado, I'll pass it on to Jeremiah to show you guys what it is we are working on.
Do we have a mobile cam we can spin around?
Yeah, we have this camera right over here, so we can...
Great. Jeremy, are we on the Sony?
No, we are not. I cannot get it working.
That's perfectly all right. Well, I'm not going to show you guys then unless you pluck that webcam off of that monitor there, and you can go ahead.
Oh, wait. Here we go. I got it. It's working. It is
Hey.
working.
Oh, cool. We got the Sony?
Boom.
Yeah, we got the Sony.
Hold up. Is...
A little bit of a glare here. I'll try to...
Yeah, that's the lab lights. We're going to kill those for a sec.
Boom. Okay. Hold up a second. And boom, we are there.
Kill it?
Okay, good. Go ahead.
Okay, you guys can see the whiteboard all right? Can you hear me all right?
Yep.
Coming in. Okay. So we went through and we completed the Banduric complex electric field setup, the original older setup from, I think it was a 2012 patent. And we have fabricated a dot product disc. A little louder?
A little bit closer.
Little
No,
bit
no,
closer?
no, no, a little bit further away, but right up there.
Good, okay.
There.
So we fabricated a dot product disc by saturating a very thin epoxy mix with tin. We ended up with 1.3 grams of epoxy to about 7 grams of tin. So that tells you just how much metal is actually going into that mixture. The reason why we want so much tin to epoxy is so that all the individual particles of tin are very close to each other, so that when we apply a voltage to any part of that disc, basically the electrons can leap through the epoxy or tunnel through it and charge up all the individual pieces of tin within that disc. But if there's a small voltage change between each individual piece, the voltages hopefully won't leap across and the electrons should stay isolated. So that's our dot product disc. It's just tin saturated epoxy pasted around and manually disposed on the top of a CD-ROM. Now, in order to create this, we also used ultrasonic transducers. We had a small mixing cup that we placed directly on top of a 100-watt transducer, and the second the cup touches the transducer, it's immediately obvious why ultrasonics are the ideal way to mix these materials, because you immediately start to see a flow taking place within the epoxy mixture as you see all the little tin particles shooting around and distributing themselves. So as you reduce the strength of that transducer, then you get a pretty even mixture of epoxy and tin, so it's distributed, without chunks of tin inside. It'll actually degas itself, which is also something else we found out very useful to note. For the cross-product disc, I'm concerned that maybe ours is not going to work all too well. We took an ordinary CD-ROM, we stripped off all the plastic, all the writing from it, so we had a nice clean surface, and that outer surface is facing directly towards the dot product disc. And between these two discs, we have a layer of approximately 30,000 volts capable plastic. It's pulled out of an LCD TV, LED backlit LCD TV, and that plastic layer is a decent voltage insulator, so that's going to separate these two discs so we can charge them differentially about 15 to 18,000 volts apart. We're using an 8.4 volt motor off of a CD-ROM burner. It can get us up to about 9,000 RPMs on our cross product disc. And then for our HV supply, we do have a Russian rectifier tube isolated HV supply. The whole thing runs on batteries. So that's our Banduric complex electric fields prototype setup. If it works, we'll be absolutely stoked, and if it doesn't, well, we probably did something wrong, and we can ask the man himself. He's pretty darn helpful as far as trying to replicate this stuff, and he's put out a lot of material that you guys at home can also take a look at, and we can link later documents that basically walk you through step by step how to replicate some of the stuff in his patent so you can gain an understanding of it. Then the other thing that we're going to be testing tonight is a TT Brown Gravitator, very classic Gravitator design. In this case, we've tested a lot of different Gravitators that are made of modern materials, epoxy mixtures with titanium dioxide and other dielectrics in them. We've never gone back through and tested what he originally stated as the use of his materials. In his early Gravitators, he used a mixture of litharge or lead monoxide, and he used a material called bakelite. If you're not familiar with bakelite, it's a very interesting plastic, very high temperature, sort of like a resin. It can be made with a 1-part self-curing resin that cures at temperature, or a 2-part resin that also cures at temperature and is a little more stable. So he mixed in a huge amount of lead oxide into his bakelite and baked these solid dielectric separators that we would place heavy materials like lead plates between, or aluminum plates in some cases. And so that was the original design. So now we're actually using litharge. We took some larger chunks of it, stuck it in a Karafi grinder underneath the flow hood, and basically let that thing go to town and grind it up into the finest powder that we could possibly get out of it.
Is there any theory that would explain why you need litharge?
Apparently the weight of the elements, or the total mass of the dipoles that are flipping around, has a significant contribution to the fields that are produced. But as far as why Brown may work, I don't even know that I would say I agree with the theories that he has presented, which are kind of wide-ranging. He has 4 notebooks, allegedly, that are online. You can find 3 of them. I guess there's a 4th one that's missing, but the third of the 4 notebooks are still missing.
Down, just push it down.
So, yeah, sorry, there's a lot going on in the lab, so if I seem distracted, it's because I'm watching this whole thing unfold. So we're also using paraffin wax as our dielectric to hold huge amounts of litharge in this test because it's another material that he had used in the past and it's available. It's something that would be of that time. And in the future, if we get any results with the combination of these two materials, we will be building an assembly with the use of litharge and epoxy plates, and then we'll be using lead electrical conductors in our case, so that there's a heavy electrical component to that system, very much like his older system. So we're basically trying to just go back to the 1940s, 1950s and see what he did, use the same materials, and look for things that we've never really looked for. Because a lot of times with modern materials, we have so many great things to work with, we think, well, we can just skip all these old crappy things and jump right to the newest and the best.
We're substituting, though, and
right.
we don't know if we missed something.
Exactly. So in this case, I think we really just need to go back in time and look at what did he have available. The other thing that we need to think about is he used a lot of DC power supplies, but if you think about a high voltage DC power supply in the time of Brown, there was a device that we use today almost exclusively for all our high voltage DC power supplies that did not exist in his time, and that is a solid state rectifier diode. See, all of Brown's power supplies would have used vacuum tube rectifiers or cold cathode rectifiers. And fundamentally, if you take a look at Banduric's system, using a vacuum tube to isolate out that system, it very well could be that the biggest reason why people trying to replicate Thomas Townsend Brown's work today using high voltage rectifiers of the solid state type may be destroying the effect because of their power supplies. And so in this case, today we're going to try to use the power supply designed for Banduric's complex electric fields discs, and we're going to use them to try and power T.T. Brown's Gravitator if we can get that voltage down low enough to not jump past the dielectric, just in case there is a relativistic Lake effect that takes place that we'd never noticed before in our very modern high-frequency, high-voltage power supplies. So something interesting to consider that we will be testing live on camera today.
Wow. Oh, that's amazing. So can you explain to us again what do you think it is about Banduric's experiment that will produce the thrust? What is it interacting with?
Yeah, Banduric's device is a really interesting one, and his theory is pretty straightforward and fascinating. Banduric makes a point of...
So let's scroll over and actually look at it. It's up here on the ceiling.
Yeah, we've got it up here, and that's the basic test rig and setup. We'll pull that down and actually we can pull that down now. We can do that now.
Dude, it's not even going through here.
What's not, Jeremy?
I told you to get this fucking thing out of here, dude. Just get it out. Just get it out of here. Alright.
Stand by, folks.
Goodbye. Goodbye. Like, why didn't... It's all coming through my MacBook. The entire... Everyone can hear me. Everyone heard us the whole time. It's coming through this microphone on my MacBook. And not coming through the microphone input sound jack on my MacBook. It's coming through the microphone.
No way, dude.
Yeah, this whole time, like on the stream, it has been. No, they could hear you. You're just really quiet in the background, like somewhere else, like in another.
Well, that's not very useful. Every time, Jeremy, I told you, man, you'll never have a broadcast without an audio issue. I think it just cursed you at some point.
It is a curse of mine. It will always be
I think some evil mad scientist with a curse beam hit you at some point.
No,
now you're forever doomed to audio issues.
I know who the evil mad scientist is that hit me with the curse beam.
Yeah, who is that? Who is that?
I know exactly who it is. I'm not going to say any names or talk about him.
Why? He must not be named? Cannot?
No, I can't talk about him. But I told him the way that I was going to set this up and do it, and I told him about like me being in charge of this stuff because I know what I'm doing, or at least I've learned from a lot of bad experience doing this, and you know, this is what happens. You know, when you don't listen to the guy with the experience, and you listen to, you know, the guy who claims he has the experience and thinks he knows what he's doing.
You should have taken advice from the
yes.
on how to do this, Jeremy.
Yes, I should have asked Tom DeLong. You notice like.
Would have told you up.
You know what? We should have hired their fucking media department, and they could hire. They could really have done with our science department because theirs didn't do shit for the past 4 years.
Well, they're obviously doing good for themselves now, aren't they?
Yeah, real good. Let me see. Where's this?
Here, I'm gonna run a test on this. Test. Check.
USB to audio. 6. Why am I now on camera like this? I'm just gonna change my starting scene transition. You're no longer.
This is where the action is. Where is the action right now? Right there. We're getting it set up, guys. Bear with us. 9036 megahertz.
Why don't you talk about, let's talk about some of the shit we were arguing about earlier today, man. I want to bring some of this stuff up.
Yeah, give me a break for a little while.
Oh, yes. Well, one other thing we were going to try is this gyroscope device. I don't have very high hopes for it, to be honest, because I don't think it was built structurally sound enough. We have some components coming in tomorrow, like some stronger servos, that will allow us to build a much more sturdy device. But basically what this is you have 4 gyros. On each side they're spinning in opposite directions, and they're sort of going to make like a swimming motion. And it's all controlled via a remote control. Here's the remote control, actually. And when we power this thing on, the gyros are all going to spin up to speed, and I'll be able to control them right here with this remote control. And it all uses just regular RC parts. Anyone can build this. It's a pretty simple device. The gyroscopes are these ultra-high precision gyroscopes from England, and they took about a month to arrive. And they have counterbalances and everything. And the servos I got, I don't think they're powerful enough. They kind of struggle with the weight and everything. So we have some stronger servos coming in tomorrow.
So you got to get this talking stick now, because that's what's,
Oh, is the talking stick working now?
yes.
Oh, okay. Yeah, so we were just talking about the gyroscope setup we have over here. It's sort of like swimming with gyroscopes. They're going to swing back and forth, and it's all controlled via remote control on this RC controller. There's a couple problems with this build. It's not mechanically sound enough. Everything is a bit shaky. We have some more components coming in tomorrow. We're going to test it as it is, just to see where the faults are and how we're going to build it in prototype B. But there may be some effect. I'm going to stick it on the pendulum later tonight, and we'll see what happens. And over here, this is the test rig that we're going to attach TT Brown's Litharge disc to. This is actually the Litharge disc we were working on earlier. You can see the material there is lead oxide mixed with paraffin wax, with aluminum plate on either side. So this is much closer to what he actually designed in his patent. We've never tried it with lead oxide before, so if there's an important component there, we're going to find out. Also, the power supply is going to be slightly different. It's going to be floating instead of the standard high voltage power supplies that we have. Okay. Are we ready? Are we ready to test it?
Everybody on? We're good.
I'm on.
Through the comments.
We are on. Let's do some, look at the comments. We have 110 people watching us do some sound. Jesus. Oh my God, Jesus. So everyone tuning in now live, I just want to let you guys know what's going on. We are I'm here down in New Jersey. Everyone, by the way, Merry Christmas, everyone who had and Happy Holidays. New Year's right around the corner, man. The end of the 2021, hopefully is going to be a epic year. We're hoping to do a whole series of anti-gravity experiments. I mean, we basically got it set up with a whole bunch of boxes and stuff full of all the different experiments out there. Anyone who's been researching this as long as I have knows everyone that's tried this and stuff. And going back to the 20s, starting with Biefeld-Brown up into the 40s and 50s with more Biefeld-Brown and high voltage stuff, and then going into Sandy Kidd and Eric Laithwaite. Inventor of the maglev train was a guy named Eric Laithwaite, and his protege was this guy Sandy Kidd, who actually built the gyroscopic motor that we're going to test too. So there's lots of different anomalous effects in physics out there, and this is the fringe, and this is we're out here to try to test these things, and on a small budget where other people could potentially do them too. So eventually, what I got to get set up after this is I'd like to do it live because this is more fun, but we also want to do some more broken down streams. I think that would be better to try to break this equipment down. I almost want to get someone who's got some expertise in like a channel like Veritasium or some of these other channels that are like Smarter Every Day, and guys like that who do some really great work on exposing science and stuff, because there's a lot more than just this that I want to get into. I think that and a lot more people that I want to talk to once I get this media set up to be a traveling road show, and we can go around the country to different labs and start exposing other people's equipment and what other people are working on, because I know we're not the only ones right now working on this. But tell you what, we've met a lot of the people that my heroes and the people that I've researched and looked up to, and some of them are on our team. I'm proud that Todd Desiato is on our team. He was in the comments earlier, and helping us out with a lot of valuable knowledge and physics information, because this is how the Manhattan Project happened. This is how the engineers developed the atomic bomb. They developed all this new technology, and now it was very complex and very difficult to figure out at the time. Okay, but nowadays you can explain how an atomic bomb works to a 7th grader. So what we're trying to do right now is really, it's on the cutting edge. It's on the cusp. We're able to do a lot of these old experiments that cost hundreds of thousands of dollars to do back in the 50s and 60s. We're able to do them now because we have computers and all kinds of other equipment that allow us to really do these experiments on a much cheaper budget. So we're able to replicate a lot of this old technology just to try and research and hopefully try and elucidate what the heck is going on by isolating different variables in the equation, and that's basically what we're here to do. Is we're the engineers, and we talk to all the physicists, and just like the Manhattan Project, all these physicists, they knew all the science of quantum mechanics and the atomic energy and nuclear science, and they applied it and gave all the equations and simplified it and gave something to the engineers, so the engineers could say, okay, now I can actually go and build something in my lab and work on this, and then I can get you a way to set up and collect data, and then we can give you that data back to the physicists so that they can analyze that data and see what works and what doesn't, and we're gonna sift through the nonsense and try to, we're here to figure out anti-gravity, and we're here to argue about anti-gravity, how it works, and we invite you to the round table to join the discussion if you think you know better.
Okay, so what do we have going on here? Jeremiah, are we ready to start this yet?
We can give it a whirl. Well, before we start anything, Mark, let's take a look at what we actually have. First off, stick mic. Now you can hear me. Alright, so here's the little test rig. We have a magnetic reed switch underneath this piece of tape. Everyone can't hear me, right? Checking comments before we get too far.
Jeremy?
No, I'm just reading. I'm trying to catch up. I'll let you guys know. I'll interrupt. They said a lot of talking. Let me see some action.
Okay, let's go to the action.
Alright, let's get there. Okay, so here's the basic test rig. We have a 9,000 RPM CD burner motor hooked up to this cleaned off CD-ROM disc. This motor is powered by an independent 8.4 volt lithium ion battery, and a magnetic reed switch here can be activated by placing this magnet on here and then flipping it down with the stick. So this allows us to turn the motor on without having to physically touch any part of it, so that electrons neither flow from our bodies into this circuit or back the other direction. Here we have a piece of dielectric material, good for at least 30 kV, pulled from the inside of an LED backlit TV. And on the other side of this rig, we have a dot product disc, where we have the surface of the CD underneath, but we're using that to distribute the electric field, and it is coated with a rather thick layer of the tin epoxy mixture on the other side. So you can't see that here. We do have pictures of that setup that we can share later, but basically this piece of dielectric is adhered directly to the dot product disc, which is fixed to the frame, so it's in place. And you can see the positive wire from the output of the isolated power supply is feeding the dot product disc, and on the opposite side, the negative wire coming through the Russian rectifier tube is feeding the cross product disc, which rotates. Now the power supply itself is running off of these two nickel metal hydride batteries, and so we get 2.4 volts roughly that powers the tube filament, which is at 2.5 volts max, so it's right in that nice range. And then we have a cheapy eBay high voltage supply, which in this configuration running off this voltage being stepped on by a diode is giving us roughly around 15 to 18 kilovolts. But most importantly, that voltage is isolated from everything else, so we have the negative output of the power supply tied to our batteries, both of them, and tied to the tube's cathode. And the positive side of the power supply comes around to the other side of the disk. So in this case, if electrons flow from the cathode towards the anode cap and they flow into the cross product disk, they can't get back out. And in order to activate this circuit so that we don't have to touch anything, just like we can activate this with a magnet and not have to inject charges or ground it, this we can just pull a paper tab which connects this battery terminal to that copper strip, and that activates the entire circuit. So hopefully we can get this thing going without having to inject any other charges. And what should happen then is as a result of the relativistic forces from the charges on the cross product disk, those charges, they can freely move around the cross product disk because it's a conductive surface, so those charges are free to migrate. And so they will. If there's any resistance to their direction of motion, they'll just move their position across the surface of the cross product disk in order to neutralize themselves out effectively, creating a current flow. On the other hand, on the dot product disk, any charges that are trapped in the little tin particles on the epoxy side coating, they can't move around because those charges are separated by a physical distance, being isolated by epoxy. So instead of being able to neutralize their charges, they'll experience an increase in their pull towards the cross product disk, but the cross product disk with its free charges won't experience an equal and opposite pull towards the dot product disk. And so the difference between the two forces of these two different disks in their own relativistic frame being isolated by a physical vacuum inside this vacuum tube rectifier, if we've done everything right, it should produce a linear force that pulls this thing along and causes the torsion pendulum to spin. That is, if it's free enough to move. If it doesn't work, it doesn't mean that the device itself doesn't work or the technology doesn't work. It does, however, mean that we've done something wrong, and in that case we'll have to reassess what it is that we've tested and try to find a better solution, or talk to Richard himself and ask him for advice. So in either case, we're about to find out together because we have not turned this thing on and tested it yet, so you're seeing it live now as we now bring it into operation.
Power this up. We have to make sure that it stops shaking because that will give us a false positive.
Not necessarily. It should produce a continuous force.
Okay.
So even if it shakes a little bit, it should continuously produce that forward force. It may be weak. We're expecting maybe a quarter of a gram.
But that should be noticeable. Also, another consideration is that we have to turn off the fans in the room so that there's no air currents. We want to make sure that the results that we get are truly coming from the Banduric device, the spinning dot product disc with the rectified, isolated high voltage power supply. And like Jeremiah mentioned earlier, isolation is key for this experiment to work, and it's possibly an explanation why we haven't gotten TT Brown to work yet, because we've never tried it isolated. So we're going to try both experiments with this isolated system. As you can see, it is very simple. It's just something that we haven't tried before.
So, do we have good camera feed on this? Do we have a clear picture?
Go for it.
Let's give this a whirl. Hopefully no, I cannot grab the mic.
Okay.
Hopefully I don't pull the battery out when I do this.
Hold it for him.
Okay, so here we go. We're going to start the high voltage power supply. The disk is charging up. We can hear it crackling. Now this shouldn't produce any force without spinning, so we'll let it stabilize, and now I'm going to flip that magnet down.
This is cool anti-gravity, folks.
And now we have to wait because the force is very small, so we'll have to wait for a while for it to exert enough force on the torsion pendulum to actually move it. It's quite a heavy mass on both sides, and it may or may not actually work because, again, we could have done something wrong here.
Hey, our spaceship is not taking off.
Not yet.
You know what's crazy is, so all the news about TTSA kind of dissolving, maybe we should kind of I figured I would bring that up, at least talk about it. you know, because it is kind of news and relevant to what's happening. Just curious, they didn't really do any experiments, even if they were failures and stuff. It's kind of I think Pal Putoff has tried a lot of this stuff too, maybe, but I don't know. It'd be interesting to talk to him. But I don't know if they're really talking to anyone at this point or what's going on with them. But in any case, anyone want to take the talking stick and talking about you know.
What are we seeing here, Jeremiah? What do you think?
Well, to me, we've either not done something correctly, or the torsion pendulum that we have set up using a fairly large and not particularly high quality ball bearing is far too high friction in order to allow this to rotate. What I would check next is probably to take this entire system and stick it on a scale. Yeah, it seems like it could be, but again, this could be air currents, or it could just be wiggling back and forth because of tension on the paracord, so that we don't know yet. I think that it's best to check it on the scale at this point because we just don't have enough force to rotate the torsion pendulum. Or it's not producing any force at all, which is also a totally viable possibility.
So I got some questions.
Is the high voltage supply working? Because I know it has problems with. Are you going to go in there like that?
Well, I'm not getting anything off that, so maybe it's not. I think the high voltage supply maybe.
Talking stick. Fry out the microphone while touching high voltage equipment. Jesus. There you go. Do not try this at home, kids.
We may not
It's
have
on.
it.
It's on. It's not producing a huge amount of voltage. Looks like we have about 12 kilovolts across it right now.
I'm glad that our cameras and the microphone is working good now. Let's go back to the live chat and check it out. We got 188 people watching right now. This is pretty epic, dude.
It's getting warm.
We got the dog over in the corner. We told her to lie down. But if anyone does give us a super chat, we will give her a treat. And in fact, we got these. What are they? The CBD dog treats, the ones with the marijuana in them.
Yeah, we'll get our dog high if you.
Yeah, so we'll get the dog. We'll get the dog stoned if you guys want. If you guys we get some stupid chats going.
Join the party right now. She's missing out.
We'll go. She's just taking a nap right now, and I don't even want to wake her up again now that she's sleeping. She's kind of in a good spot, man. The dog, the lab dog, is kind of like, you know, I don't know. I don't know how Jeremiah doesn't feel too strongly about the lab dog, and I'm kind of like neutral, you know, in the
It's
whole
a high
thing.
voltage environment. I don't think it's appropriate to have a dog potentially running around and touching high voltage wires or nibbling
Could be
on
a hot
cords
dog.
that carry potentially huge currents. I mean, it's just not a good idea.
Yeah, hot dog, right?
Her name is Pinky. She's a good dog. She
Unless
knows to stay in her
you
corner.
want her name to be Crispy, keep her away from the gear.
Hey, I know plenty of geniuses, guys. Look, I tell you what, they're not at Harvard. Harvard's where the stupid kids go. They're all the rich people send the stupid kids. Your kids are really, really smart. They don't go to Harvard. Anyways, let's talk about, you know, who's smart and who's not. You know, geniuses, and geniuses really just trying something different and trying something new and succeeding. That's really all genius is. It's like a bunch of different people tried new shit. They have different ideas, and they're like, oh, you know, I'm going to combine this and this and this and try this. And then they fail. And then this person tries this and this and this, and then they fail. And then one person tries this and this and this, and then, oh my God, that worked. You got the right friggin' recipe, and you succeed. You're a genius. No, it's just you just found the right recipe, and you worked really hard for it to get there, and to get all the right pieces of the puzzle to actually figure something out. You know, so when I talk about pieces of the puzzle, yeah, I think I've been doing this long enough that we've got a lot of pieces of the puzzle on the board right now. We've got a lot of the data. We've dug up a lot of data that was hard to find, put a lot of data on the board, and now it's about analysis. You know, and analyzing that data and reducing that data down into information. And then I always say, you know, in any kind of intelligence operation, you know, when you're talking about genius and intelligence, it really should be about distilling that intelligence down into actionable information. In fact, I'll draw a graphic for you if you want. Up here, real quick. I drew this earlier. I'll draw it again. This is the pyramid, and this is the data down here. This is all the data, right? then we have info. This is all the information, and we do analysis to get it to, we're trying to do analysis to get it to go this way. And then this very small tip at the tip of the pyramid is your actionable intel. It's what's actually actionable, what you can actually act on and actually get somewhere with and do something with. And that's basically like what this is all about. You know what I mean? We're in this process right here, and we're trying to accelerate that process because this is kind of how science happens. But we're trying to accelerate the process at which science happens because the current way that we do it with these with papers, and this is peer review right here. You guys are the peers. We're getting your review, and we're getting your input and crosstalk and ideas. We've gotten a lot of great input from people who say, "Oh, you're doing this wrong. You're doing that wrong." Awesome. Thank you so much. You helped out a ton to get us from here to where we can actually have actionable intel. Actually actionable intel. Intelligence.
This is really the only part that I try to concentrate on, because like you can have all these great theories, and so far you can have all these great theories, but if it doesn't work, if there's nothing to try in the lab, then it doesn't really help me that much. In fact, for the dynamic nuclear orientation experiment, I've had so far about 5 different candidates for theories about why it would work. And bottom line is, the question is, does it really work? If it works, then it's great. If not, then...
So this is where I think Bob Lazar and Randy Kramer and all
we
the...
just got a $5 super chat.
These guys sit in this this level down here, I believe anyway, called infotainment. They haven't told us anything that's been actionable. If Bob Lazar told us something that's actionable 30 years ago, we would have anti-gravity craft by now. But none of his stuff on element 115 or any of that stuff led us to anything
That's because
actionable.
it wasn't information that came from him.
Oh,
yeah. Okay. I actually did a presentation on this at DNNY, the Disclosure Network, New York. Bob Lazar, I believe, saw a real craft and was fed disinformation as to how it worked, because that's the holy grail of science. That's the entire secret. But when he went inside the base of the craft, he used his own intuition, and he saw these tubes. They told him were gravity generators, and he said they actually looked like microwave waveguides, and that was his own intuition. So that's the only thing that he really shared with us, other than his story about what he thought he saw over there. And with the Alciphon experiment with dynamic nuclear orientation, you do need microwave waveguides, and it's actually the sticking point. What the hardest piece of the puzzle for our dynamic nuclear orientation test is the freaking waveguide. We're trying to figure out how to make that, how to test it, how to figure out when it's in resonance and when not.
Well, maybe Bob Lazar knows how to make the waveguide, because he was the guy. Well, he was the guy that figured out that it was element 115. I mean, none of the other physicists could figure out that it was element 115 until Bob came along, and then all of a sudden we knew we figured out.
That's a whole bunch of hogwash. I mean, element 115, element 150, all these elements are going to exist at some point. If you stick enough matter together, you eventually get that, but it's not going to be stable, and it wasn't stable.
$5. We got a dog treat.
Oh yes, let's give a treat to Pinky. She's gonna start to salivate, and she'll come out of here soon. So I saw Dan mentioned Bob Lazar as well. Yeah,
Hey, turn that camera over. Let's get the dog going. Ready? Proof. We actually follow through with real world.
Oh, she's waking up. Oh, she's sniffing it.
Gave her a dog treat for the person.
Oh yeah, there you go. There you go. The dog is really happy. Thank you.
So anyways, you know that when I did my research on Bob Lazar, I do what's called source in intelligence, and like it's really important about sources when you're doing research and when you're doing presentation. It's really important you share your sources, because then other people can be like, well, where did this person figure out all this information, and how good of research did they do? And when they look at your sources and all your sources came from the same person, then it's like, oh, well, they didn't really do a lot of research. They just listened to what one guy said about this, and they didn't really back check and do the real legwork to figure out what was involved in that. So when I did the research on Bob Lazar to try and figure out his sources and look for his sources on the element 115 stuff, what I found was the May 1989 issue of Scientific American magazine, which had 5 pages talking about element 115 and how it was going to be used in the future of energy storage, because it's such mass per area. It was such a high density packed mass energy, and mass energy conversion equals mc squared. You got a lot of energy packed into a small space. There's a whole article about it, right? The same year that he
That's
it was.
possible, but that could have come from somebody else.
That was the year he came out.
But that could have come from his boss. He's just saying what he heard from
That
his
could have come
boss.
from his boss. It came from the two guys, Gottfried and you can look up the scientists it came from.
I'm saying that his boss could
It's a
have
good
read
theory.
that article. His boss could have read that article and fed him that piece of disinformation because they wanted to put out disinformation with Bob. But the only piece of information that he actually saw over there was the microwave waveguide, base of the craft.
It doesn't make any sense, dude. Because I don't know. I'm not gonna.
That makes sense. That's what I would have.
There's too many guys that came. Other guy came on the APEC conference and tried, talking about Bob Lazar, and he didn't have anything else to share. And I was like,
We shut him up.
and
I shut him up. I
yes,
was like,
it's unobtainium regardless, and it's a waste of time and it's a waste of effort. And I know a lot of people are here just to like talk about that kind of stuff and waste time on it because that's what they do. But this is real info, and this is how we get information from this is figuring out where we can get to because. Element 115 didn't help us in 30 years get from there to there, and maybe they've already figured this out somewhere. And if they did, we're gonna try our best to figure that out. In any case, operate the talking stick. Yeah, and if anyone wants to grab, you got to grab this mic if you want. The sound's too loud now. Okay. So turn the mic down. No, it's just because you turn it's too close. If you get the mic too close, then the mic gets a little too loud. That's all it is. In any case, what the heck is happening here with my screen?
Jeremiah, you want to explain to everyone what you're doing?
Oh, Nassim Harriman. I met Nassim Harriman actually. That's cool. People are talking about him in the live chat. I met him, and that guy's like really egotistical and full of himself, and he doesn't really know a lot of science, and he doesn't like to listen to a lot of science and listen to anyone else's ideas. He's really self-centered, really opinionated, and like really super egotistical. He thinks he's like, the next Einstein and stuff, and so do a lot of his followers. He doesn't want to listen to anybody else, and he doesn't like to have other people that are smart on because he's too afraid they'll make him look stupid. And I mean it's crazy. He says the right things and has that right follower, and he has again the right media. He has that whole media empire and stuff. It's really crazy what he's able to do with that. But where's the OBS now? There's OBS. All right, so. Yeah, Nassim Harriman, his group is working on some kind of anti-gravity and stuff, but they've gotten a lot of money, like some of these other guys. They've gotten tons of money for experiments and stuff. But really, I'm sad that they haven't really produced anything and really aren't, engaging enough with the mainstream scientific community and looking for, there's all this talk about a big giant conspiracy with the, that the mainstream science is all wrong and that, we're all stupid and misled and miseducated and stuff. And so it is kind of a thing. I don't have a PhD. I have a bachelor's degree in physics, and I'm probably the most I'm the most technically educated person here in this, but these guys have been doing hands-on stuff, so they know a lot of this hands-on of these experiments a lot better than I do because they've been working on it. It's all about experience, and so that's exactly why Elon Musk hires people that don't have PhDs and don't have master's degrees. He doesn't care about that kind of stuff because it's all about experience. And it's all about your level of skill and what you're capable of, because it's real possible for a lot of really great-minded people to accomplish amazing things who aren't super educated, but it's also we can't just throw out those people's opinions because we don't agree with them or we can't understand them and stuff. We need intermediaries who can kind of be this level between that hard level of science and this laboratory stuff that we're trying to do here, this trench work. So we are we're here in the lab, and I don't, the Bob Lazar craft. Oh, wait till we talk about this later. I had some cool ideas. I can't wait to get off with this experiment and get the klystron out and talk about some of that stuff. Because we had the klystron, and I was doing some research on the klystron, which we'll talk about that later. I'll bring that up when we bust that out. Well, anyways, more on Banduric, and this is like this is the Townsend Brown.
This is Thomas Townsend Brown. We're measuring it on a scale this time.
So we're gonna measure it on a scale for the first one, and yeah. So Townsend Brown, basically he used glass, which was a good dielectric, very cheap and very common at the time.
Don't remember using glass, just as a quick correction, but no, he used a variety of materials. Yeah, Brown used a variety of materials. He used everything from natural clays that he would isolate electrically to sands and other variety of other materials. As we mentioned earlier, he used bakelite, and he used various types of waxes, including carnauba wax, paraffin wax, beeswax, and he used also a variety of different cements that were available in his time as dielectric materials. And he had noticed an interesting response with some materials that they had apparently a different gravitational mass from their inertial mass. And the way that he would differentiate between the mass of one of these gravitational isotopes is he had a centrifuge in which he would place some test tubes that contained some percentage of water, and inside the test tube with water would be a smaller tube or a smaller vial that contained the gravitational isotope. Now, if you set a test tube and you float a smaller tube inside of it with some material, gravity will pull down that material up to the point of buoyancy, where that material sits at a certain level at the water point, so you can see where gravity is pulling down on that material versus the weight of the water. When he would spin up his centrifuge, he would notice that some of these materials would sink deeper into the test tubes, and some of the materials would begin to become more buoyant and sink back out of it. So this demonstrated a clear difference between gravitational inertia gravitational mass and inertial mass, that there was really a difference here, and this is in his notebooks, in his personal lab notes. Also, he talks about this in his patents. And some of the strange materials that he noted in today's test were using litharge or lead oxide, which was one of those gravitational isotopes that exhibited these strange properties. Only a small percentage of the actual lead oxide is apparently responsible for this, so it's possible to isolate out the individual pieces of it that are using electric fields, but in this case we didn't bother. We just simply used it stock and ground up masses of powder, and hopefully enough of that is a significant contributor to the gravitational isotopes he talks about. But we'll see through experiment if there's any relevancy in this particular investigation.
Okay, are you ready to run it? This is the gyroscope thing that we're setting up right now. Coming out all crooked.
I'm going to set this down.
Tom, can you grab the other side? I need to release it for a second.
What's up? Shout out to everyone in the live chat. What's up, Dan Banker? What's up, Renee Cruz? How's everyone going? Mr. Magoo, Yvonne Twitch, Twin Peaks Fan Club, Anthony D. A few pounds of turquoise. Why not spinning magnetic fields? Yeah, well, the spinning magnetic fields thing, that was all. We already had a lot of those guys on with the SEG. It's amazing, the SEG, like they built this whole complicated thing, and then they did all the math out. Those guys that were on, they did this whole calculation out, did all the math out, and reduced it down to that one simple thing. What was it? Just like a magnet with 3 rollers is all you really need for the most simple form of the SEG.
Well, even in their application, they didn't really use the same field geometry. Yeah, even in the replications that I've seen, Searle. I'm not going to say my opinions on Searle. I'm guessing this is the cam that's active. Yeah, I won't say my opinions on John Searle. What I can say is that in the replications I've seen of people trying to properly do Searle stuff, there's a specific geometry of the magnets which is really important. That if you roll these magnets along a piece of magnetic viewing film, you'll see a sinusoidal waveform produced, because instead of being an axially polarized magnet where one side of a cylinder is north and the other side is south, if you were to imagine a flat plane between the north and south, if you tilt it on its side to some extent so that one side of the plane touches one edge of the disk and the opposite side of the disk on the other side has the other plane, basically you create this diagonal north on the left top side and south on the bottom right side, for example. You tilt the magnetic axes from being centered at an angle. Then you have a Searle magnet, and this produces a fluctuating electric field as the magnetic field travels through space that moves up and down, and as these rollers spin around, and begin to accelerate, they produce stronger and stronger radiated magnetic and electric fields. And this is supposed to help in the effect. Now, whether the device works or not, I can't say. I've never seen anybody succeed in trying to make it. I have seen people spend hundreds of thousands of dollars attempting to make it and receiving anomalous effects under very specific conditions, but again, nobody's really been able to prove it out, so it's not the place I think we want to invest our time or our resources in. But nevertheless, if somebody has a better idea on how to do it, go right for it.
Yes, and we can refer you guys to the right people if you're interested in that. Also, if you're interested in the electric universe theory, you can go to Ken Wheeler's channel for that kind of stuff. We're not doing that here. We're doing something different, and it's important that we all try different things and see who succeeds first. Anyways, I get some live chats here for some donation. VPXM, what is up? Thank you for the kind donation. He gave us $20 in the form of I think 2 different donations. So we're gonna go and give the dog another treat here. So you all can thank. You can thank the live chat over there. Why don't you give the dog a treat? It's your dog, man.
It's the lab's dog.
It's not a lab. She's a mutt.
She's actually an Indian pariah.
Pariah.
India.
Oh, very good. Tesla tube. Mark, what question would you ask Elon Musk if you had the chance?
Oh, that's a great question. Thank you for the question. What would I ask Elon Musk if I had the chance? Why isn't he investing more in anti-gravity right now? Or, better yet, he's been asked this question several times about anti-gravity, and his answer is always, we need to get to Mars in order to have the impetus to build, to work on this stuff. Why do you have to go to Mars first? Wouldn't you invent the way to get there before getting there? Because rockets aren't really going to cut it. That's what I would ask Elon. And he would probably ask back, so how do you think anti-gravity works? And then we'd have a long conversation.
Yes, and I'd have a different conversation.
I'm sure you would.
No,
I'm sure Tom would have a different conversation as well.
Yes, this is what I love about this.
But at least it would be a conversation, and I'll have actionable things that I can try in a lab that will prove it one way or another and actually build a craft if it works.
I mean, we like conversations too. Shouting matches are cool too. The audience likes those as well. If Jack Sarfati wants to be a guest and come on, I've already invited him. I want to get Jack on. So Jack, please come on and let's have an argument and let's disagree, and we can all be better for it at the end of the day. So anyways, yeah, this is really cool setup. We have a set rig. I'd like to make this a little bit more sensitive and to motion. Look at that. You see that? There was some torque in there, and it just twisted all of a sudden. You could see the static friction. I don't know if the camera caught that, but the string just tugged all of a sudden there. So which means there was some static friction built up in that string as this thing's rotating. And then as it built up, it just it spun all of a sudden. So I thought that was.
That's an important point. But you got to understand that this device we're dealing with here is much higher power than the device we were working with earlier. This is putting out more like 30 watts, and it's gyroscopic energy that we're trying to turn into a linear force. So if this works, we're expecting quite a bit more torsion than the previous experiments. Also, these devices weigh quite a bit more because we're dealing with all these gyroscopes, and we have to have a counterbalance on the other side full of water. So there is expected to be a little bit of a tension on the bearing. And the bearing is from a pair of rollerblades. It's actually a brand new bearing, and we removed the oil to make it a little bit more frictionless. Somebody asked in the comments, what do you think of Alexei Cherkov's device? We actually have some inside information on that. Did you hear the latest on Alexei Cherkov?
No, I haven't.
So this is with Tim Ventura. He was actually in contact with Alexei, trying to get him to speak at APEC. And
this is one of the Russian scientists, right?
That's the Russian dude who has all these flying discs devices. And apparently Tim was offered by Alexei to purchase one of these devices for $2,000, and he would send it to him, but it won't work without Alexei being there because he knows how to twiddle the dials. And then when we asked him, I think Jeremiah was in on this conversation as well, and he started pushing us toward the work of, was it Grabinikov, the guy with the beetles?
Yeah,
the
like
beetle
he
wings.
talks about in his videos. He talks about the work of Grabinikov in his device, and he references it in the structure of the aluminum separator between the positive and negative plate that rotate. And apparently, what he does is he's a dimpled aluminum type of material where there is a very rough surface with lots of little pits and valleys. And this is apparently very important, directly resulting from the findings of Grabinikov. But when one of our members of our private research group in our WhatsApp chat contacted him through email more recently, he wasn't really interested. He wasn't really interested in trying to help us out or give any information. Instead, he sent the member of our group to look at John Searle's work, which is kind of strange. Didn't bother to mention Grabinikov at all, which is the basis of his videos. So it was a bit of a divergent response, and we wonder if there's really any validity to it.
Very interesting.
So,
yes, this is cool.
I mean, I have my own opinion on why someone would divert and not answer the question directly, but again, there could be other reasons that I'm not considering.
Right.
I've just made my own personal assessments of it, and I won't bother to show those.
Very good.
I just want to make one comment that his videos are in very bright light, and it's very easy to hide a string in those lighting conditions.
Yes, and if you want to know how to do that properly, pantyhose liner, if you just take pantyhose and you rip them apart, the string from pantyhose liner is actually very thin. That's what magicians use, and it was recommended by a lot of film and production special effects artists. So yeah.
We're obviously not using any of that kind of stuff.
We don't use any of that crap
Yeah,
here. You
what you're
won't
seeing
know.
here is real. It's live. It breaks. On camera. The microphones don't work. This is live. This is
Not about that life.
Sunday night live in the lab.
Yes, ladies and gentlemen, it is Sunday night. We have a $20 donation from Carl Christofferson, the crossbar that has about the friction in the hooks connecting it to the vertical bar. How have you minimized that? Seems like hook against hook. Well, that's not where the friction is. Let's zoom in on that setup and give them a better.
The pivot point is right up here.
Yeah.
And you can see there's actually a bearing. There's a ball bearing right there. That is where all the friction goes. So it's this white plastic PVC rig is going to be spinning against that wooden block, which is in turn attached to the ceiling.
Yeah, so this is really what I was talking about earlier when I saw it spin. I saw the string had it turned around and built up some tension in here, and then all of a sudden it built up enough where it overcame the coefficient of static friction, and then it moved and turned until it straightened out. So there is some static friction apparently between these two things. It's not a perfectly frictionless connection there. So that was something that I had noticed and tried to point out earlier. But yes, indeed, we should maybe work on that for our perfectly frictionless torsion pendulum.
Yeah, our
But
torsion pendulum is lacking. It's lacking quite a few things, and one of those biggest things is the freedom to move freely. So that's kind of a problem. We just did build it yesterday, so again, we're still working through iterations.
Right. So the idea is that if these experiments had some reported effects, should be able to replicate them and hopefully see something, and if they don't, then we'll see them and we'll put them aside. We can pull them out if someone comes across something where they bring to our attention. We'll always have the equipment there to do it, and if anyone wants to try it, we'll have it here at the lab to redo any of these experiments, and that's kind of what we're having set up at our Gravitics lab. Is all the different gravity experiments that we can think of, and any others that you in the audience or anyone else devises or comes along with. We're pretty much all open ears to the cutting edge on this stuff, and we want to just give a history lesson for all this other stuff, just to make sure other people don't fall for some of the stuff on the internet and waste their time on stuff that doesn't work. They can come into our lab and check it out. You can write to me and we'll give you, there's an open invitation there for people. We also have a database that we're compiling, and if people want access to that database, it is sort of a private thing. There's a lot of information in there, and a lot of it's for educational purposes, but for copyright reasons, we can't just post the whole database out there openly. But if anyone wants a copy, enough people have it where it can never, be suppressed or erased from the history books at this point. But if you'd like access to that database, get in touch with us, and you can come here to the lab. A couple of scientists have already come down and shared some information and gotten a copy of that database and taken it home with them for their own private research. So this is what we're trying to get set up as the community of scientists to make this happen.
Carl Christofferson just gave us a $20 super chat.
Yes, I saw that. I read his chat. Why don't we read that again? I want to make sure I got that. He said, he gave me another one. So that was thanks $20 super chats. That is amazing. Thank you so much. So yeah, so we have that anti-gravity patent from the Navy, the Sal Pace patents. We've looked at those. I've also looked at the John St. Clair Google patents. Those I think are disinformation. The John St. Clair patents. I'm not sure, man. That one came out. The TR3B one's all you can find on Ed Fouché now. You can't find nothing about the quasi-crystals and metamaterials that he talks about. And then Ed Fouché, that whole thing came out on third phase of the moon like 2 days after Ed Fouché died. And I was like, this is like coincidental, or it's got to be, because like there's no way like 2 days after Ed Fouché dies, this big thing comes out about the propulsion system, and it all goes away of the wayside. And I want to talk about some of that stuff, because the Fouché stuff, I've done a lot of investigation and research into that, and there was some experiments with a guy who worked for GE. He was an engineer named Henry William Wallace, and he worked for GE, General Electric, in Valley Forge, Pennsylvania. And he did a lot of these experiments with rotating mercury and different doping of the mercury. And the doping is kind of like the doping that happens in silicone to make it positive or negative. They add these different elements to it and these different isotopes of elements to give it these intrinsic spin characteristics. And it was all about spin research. Now, if you go and read the papers about it, it was all about researching magnetic gravitomagnetic fields, kinemassic fields, which are gravitomagnetic fields, kinemassic fields. That's what they called them. It was basically another word for gravitomagnetic fields. And that research continued up all the way into the 90s and the early 2000s with NASA and NASA's Gravity Probe B. So anyone who thinks that this isn't real or serious, real information or real research, they need to go and Google some of these things that we're talking about. And
right now we're going to try the swimming gyroscope, and this thing sounds really cool.
Yeah, let's turn some more shit on. I want to see this. This is great.
Here you can hear the gyroscope slowly turning on. We had to put a row of resistors in there because they were turning on too violently when we just powered them up straight. So now it's running through the row of resistors. When I turn the resistors off by shorting out the circuit, you're going to hear them go into high gear. Okay. 3, 2, 1. Power on the remote control, and now we're going to go power on the servos. 3, 2, 1. There we go. Just stabilize the device. Like I mentioned earlier, this device is not very stable. The gyroscopes are being held by these tiny little servos, which are not adequate, but we will try it regardless.
Yeah, I can see a lot of instability in those motor mounts and the servo mounts where the oh, that was a little hyperextended there. You got some collision going on there. Again, we need to eliminate that static friction point there to make sure it's not just pushing off of that as a pivot point. Because any kind of place in the system where you can have a buildup of static friction, and then a sudden release of static friction will create a push point where you can push off of. But this is interesting because it has turned, it has rotated about 30, 40 degrees so far. There, it just rotated backwards, and now it's also colliding with the pin in the center. I think they need to be mounted further. Yeah. So we'll have to put
This is a work in progress.
we'll have to rework on that one. But yeah, that's cool that you set that up. That was cool. People want to see stuff like this. They want to see us working on it, at least building it. At least we know what's wrong and some of the design flaws in the system. And if anyone has any recommendations, draw us a sketch and send it to thealienscientist@gmail.com. Thank you.
It is kind of working. Look at that.
We got another $20 chat, didn't we, here in the live chat? Let me just check this out
It's
here.
actually working. Well, actually, it depends on how you pulse it.
It kind of is working, isn't it? It does actually look like it's working. That's weird. I wonder if it is.
All right, now it's working. Now it's actually walking. See, here, it's walking around. See, this is why, like, I drew a box around this, and I tried to use my physics theory to try to explain this, and my theory and all the math that I could come up with, said that this wouldn't work, and now we have some kind of experiment where apparently this works. So this is interesting. We're gonna have to again. It almost seems like it works, doesn't it? This is very interesting.
I'm telling you, man, I'll just die if it's gyroscopic propulsion that ends up getting us there. If it's gyro propulsion.
Yeah, it's just gyros, but the best way to do it is with the TR3B and a torus full of rotating mercury plasma, right? Jesus. Could you imagine?
I hope it's not something that simple. I don't know, man. I really want field propulsion. I want field propulsion with no moving parts. That's the ultimate goal.
You know, that goes against all the stuff that I think it is about
It
spin.
is working. Tom here is at the controls. He's trying to use just one gyro to make to get it in resonance with the device. I don't know if that's actually field propulsion if you're going in resonance with the entire setup, but we are getting it to spin around.
Nudging it forward, inching it forward.
Just one gyro is being controlled right now. Tom, what method are you using to control?
Trial and error. Trying to produce a torsional moment in the entire system. I assume that's the...
Alright, keep on doing what you're doing, Tom.
I can see what he's doing. He's timing the pulses with the frequency and the pulse.
We just killed its forward momentum. If he can get that thing going again in the same direction, he's very impressive.
So we just killed its forward momentum. So if he can get it going forward again in the same direction, then we'll be impressed. So I just want to show real quick to. Yeah, can I get in here?
Should be possible to move it equally well in either direction depending on the speed change between the forward and the reverse stroke.
Well.
It's designed to be moved diagonally.
So Tom's sitting here with the controller. Why don't you hold the controller up a little bit higher, or step, just so, yeah, right there. There. That way people can see your control. We got the servo motors and the device up there hooked up to a RC.
It's designed to be ran like that. We might have some. This tire looks like it's about to fall off.
That doesn't sound good.
Okay, we are running into some technical difficulties over here.
Can we postpone this one? Let's try to get something else set up.
Power this one down.
Let's power this one down. This was I want to get this set up with a little bit better motors there, a little bit better coordination on the and maybe a little bit bigger spacing so they're not hitting each other too. I don't know, or something.
Yeah,
But
we definitely need to rethink this experiment. We actually have parts coming in tomorrow, stronger servos, and we picked up some aluminum bracket that we're going to be using to attach to the gyroscopes instead of these little spindly arms that it came with. They're not sufficiently strong enough to hold the device, but we have seen some movement over here, so it is very promising. And we're going to be going forward. We're going to be moving forward on this experiment for sure. Kind of sounds like a UFO now.
right.
Like a flying saucer.
Well, you got the sound right anyway. Now you just need you know, the anti-gravity part.
Yeah.
Yeah, also looking to inject the charge without physically
I'm actually.
Oh, we got another donation from the same
Can you
dude
grab
there.
the water?
This is cool, guy. Thank you so much. So yeah, that was interesting. I'm not sure if it developed momentum in that direction and just kept going or something. I'm not really sure, man. Oh, John Hutchison. I acknowledge John Hutchison's work. We're actually going to be doing some experiments. We've talked to John Hutchison and been in communication with him a little bit because we're trying to get more information on what exactly he did and how to do it, and if he can come down and show us some stuff. We also want to get those. I want to get those crystal battery cells that T.T. Brown had talked about or invented, and.
Victor just gave us some information on the
Oh yeah, he did, huh? So hey, no. I got you guys all on the other camera for right now, so it's not even on that one. So
Oh man, I've done the ultimate sin now. Oh boy.
pretty cool stuff. Anyways, hey, here.
He's gonna come in.
Anyone got something to say? You want to take this mic real quick and?
Oh, we're gonna try the T. Townsend Brown experiment next. Oh, we're on that microphone.
You're
On that camera. So we're going to try the T. Townsend Brown experiment next with the isolation setup. And right here we have it set up with the 2 cups of isolation to keep the high voltage separated off the table. Of course, high voltage static fields will change the reading on a scale if they are pretty close to it, because the scale uses piezoelectric effects. We have to separate them. This is around 7 inches of separation, so it should be sufficient. We're looking at 0.771 grams, so it's about 3/4 of a gram. And when Jeremiah is ready, we'll power it up and see what we see. Jeremy, is there a way you can transfer the camera to the mobile one so we can get a readout? Yeah. Transfer the readout over. Okay, you can talk and tell them what's going on.
Yeah. Okay, let's take a closer look at what's going on here. So, on this scale, we've got the T.T. Brown, Litharge, paraffin assembly. We have the negative plate, or the wider plate, facing upwards, which is going to go to our isolated negative output electrode, and we have the positive facing downwards, which is going to go to our positive isolated output electrode. Now, in this setup, there's no real good way to connect the wires from a power supply sitting on the bench to the sample sitting on the scale. So in this case, neither wire is physically touching. Both the high voltage input wires will be connecting through the air through ionic charge alone, which adds even farther isolation from that whole system. And so I can move this box and power supply around, but the scale does not respond because they're not physically connected. So even though we're going to lose some voltage in these air gaps, it's not really that important, since I'm looking for a change in this scale. Now I've taken a small weight and I've popped it on top of this thing just so my scale doesn't read roughly 0, where it's nulled with the sample weight. So this just gives it a positive reading, continuously keeping it active, so we can see a small change if one does occur. Oops. Still trying to get that thing to flip. Come on, come on. Alright, gonna try that one more time. There we go. Alright.
Pinky's ready too.
Well, momentum seems to not be. Alright, well, there we are. Then, in good fashion, to keep an isolated supply, I'm going to go ahead and pull this lead out.
Okay, there we go.
Okay, I've got to set the mic down.
Okay, it's powered up. Wow, that's exactly what he saw. It was, or rise and then a drop?
We'll have to wait yet to see. We'll have to wait to see if there is a stable and consistent change.
It's going back.
It's supposed to drop after a series of seconds to its original mass. And in the opposite polarity, we should expect the opposite effect. So in a moment, we'll flip this disk upside down and check it again. Doesn't look too stable to me. I think this is a invalid test.
You gotta unplug it from over there.
Silver cord.
There you go, much better view now.
Can you kill that other little one too? The little light?
Power is disconnected. I'm going to manually discharge it. Well, that was inconclusive.
Do we have a negative output from that power supply? Because you mentioned that it usually goes in the direction of the positive, right?
Yes, we made the positive the small plate in this case. So now we're going to invert it, and we're going to try it in the other direction. So now the small plate will be charged negatively, and the large plate will be charged positively. This is a proper T.T. Brown setup where the large plate is the positive plate, supposedly producing a significantly larger force than in the inverted direction. But I have to make sure the wires are not physically touching.
Again, guys, this is what real experiments look like. These are things that you could actually do in your home laboratory, if you have one, or your garage. The experiments you've seen tonight were not really that advanced in terms of the greater scale of things of the other devices that we are working on. These are.
Give Pinky some treats.
Oh, Pinky deserves a couple treats.
We got some live chats. Let me just go over to here. Make barium titanate cone top bottom electrodes. Embed it in fused quartz.
There, Pinky's waiting for her treats.
Barium titanating quartz, Jeremy?
Jeremy, Pinky's waiting for her treats.
Oh yeah, let's go get this dog stoned with some CBD dog treats. Here you go, girl.
Oh, look at that. She's excited.
Good girl,
She's excited.
Go get it. Get it. There you go. She likes me. She was really scared of me when I first came here to the lab, and she wouldn't come near me, and she used to growl and stuff. And now she's like, she won't leave me alone. She like jumps up on me and she tries to be my friend. Come on. She's in her passive mood now. Good dog. Good dog.
Okay, so how's our TT Brown?
Let's check it again. Okay, here we go again. We're going to power it up.
Wait 1 second. Camera's not ready yet.
Perfectly alright.
Okay. We're ready. Go ahead.
Alright, setting our electrodes. So again,
I got it.
I'm pushing down on the box to show that when I insert the battery, it's not going to cause the scale measurement to change. It's a little unstable because the scale is cheap, but here we go. Let's give it some power and see what happens.
Oh, wow.
Again, those wires are not physically touching. There's no physical contact with the surfaces, or there shouldn't be. Oh, I think our wire may be shifted. False positive. Let's restart the test.
Let me see that mic. I want us to talk. Get a shout out real quick. So Andreas Lucis, make barium titanate cone, top/bottom electrodes. Embed it in fused quartz cylinder together with a coil and diode string. Power with sawtooth wave from an outer coil. Man, if you could draw us a diagram and send it to us, thealienscientist@gmail.com, that would be that was something we could definitely build. We have some barium titanate. We have a bunch of other materials and compounds.
We have calcium copper titanium oxide, which has a dielectric strength of 200,000. Barium titanium only goes up to 60,000, so it's maybe even better.
We are isolated again. We're going to try this a second time.
Oh, we're isolated again. We're going to try this a second time. Just 1 second.
All right, here we go. We're going to power this up again. Better isolation. The wire moved in the middle of the test, which was no good. Electrostatic attraction.
Power's on.
Oh, the scale is doing its wonderful little auto zero thing. That's real fun. Good quality, cheap eBay
You
scale.
just removed the battery and it went up in weight, though.
I did, but the scale is trying to show a zero that's not really a zero because it wants to make itself look like it's more stable than it is. So I have to add some weight on top of it so it doesn't try to drop to zero, dealing with cheap Chinese products that have integrated programming, which makes them inaccurate. Alright, let's try this again.
Power just turned on.
Again, those leads are actually not touching this time. I have a very clear view of both of them.
It went down from 890.
There is no physical contact this
to
time.
820, 817.
And now it should begun to come back at some point in the opposite direction. It responds for a period and then it should come back. It can take up to several minutes according to Brown.
Well, we'll just keep it going then, I guess. 820 still. As you can see, the wires are not physically attached to it. There is a little bit of spacing over there.
I want to make sure that
It
this
should be coming back up. Oh, look, it's coming back up. It's coming back up. That's exactly what Townsend Brown said, right?
It's supposed to come back up, yeah.
And eventually, even with maintaining the field,
I just touched it. I think I just screwed with it.
When you flipped the Brown cell, did you change the polarity as well?
I did just this last test. The wire and its colic is slowly draining itself down. So what really needs to happen is we need a better test rig. And these wires being plastic jacketed, they have to go away. We need solid copper. And we need that copper to stay exactly where it is. So I'm going to rebuild this in the next 20 or 30 minutes here, and we'll try this again with a better test setup, because it appeared that we had an effect for a period of time, but the wire is constantly changing their geometry and flexing. That's no good. So we'll have to check that again.
what gauge wire are you going to use?
In this case, it doesn't really matter what gauge wire I use because we're talking microamps of current. It just matters that the wire doesn't have a plastic jacket made of stranded internal conductors that bends over time, that's heat sensitive.
When you want to use something like super thin so that there's not much torsion on the wire?
I'd want to use a fairly thick wire, like the 13 gauge we have out there, magnet wire, so that the wire can be extremely close to the actual sample, but not quite touching it.
Oh, okay, I get it. Because it's not actually going to touch it. We'll make a sharp edge on
Yeah,
the
and this
13
time
gauge.
we'll put some spherical terminals on the test sample instead, because we have plenty of them from the multiplier, or from the Marx generator.
Very
And
smart, yeah.
then we can avoid any possible electrostatic leakages that could be affecting it. So let's do all that. We'll do that now, and you guys can continue the show.
Question from the live chat is, have you tried Stan Dio's anti-gravity concept? Yes, I did build that birthday cake thing and try a bunch of different experiments with that with some power supplies. That was one of the first anti-gravity experiments that I think I ever tried way back in the day. So for sure, I have tried that, but that's not his only work, I believe. That's an easy enough thing to build. We have quite a bit of cool stuff out in this lab. If we're going to be able to show you guys, we have a whole big coil full of copper wire, and we're going to be we have plenty of copper wire that we could be making all kinds of stuff. So maybe we'll put that together and then throw in that Stan Dio birthday cake now that we have a much higher power supply, a higher voltage power supply than we had previously when I tried that experiment like about 10 or 12 or 11 years ago.
Well, let me ask you about that. Mr. Alien Scientist, tell me about your Stan Dio birthday cake Lorenzo generating assembly. How did you assemble that? Tell me a bit about it.
That was actually while I was working with I was working with a very interesting character as a consultant to help him with, he was trying to put together a TV show, way back in 2009, and this is the individual that I actually got the Podkletnov interview from. He flew to Tampere, Finland in 2004 and got the Podkletnov interview.
Which was an amazing interview, and we're all thankful that it exists, because had no one gone out there and made that happen, we would have never had the opportunity to hear about what he was doing at that time. It's the only interview quite like itself. I'm glad it happened.
Yeah. So there was that guy I was working with, and we were trying a bunch of different anti-gravity experiments, and of course Sandio was one of the ones that was big and popular and around at the time. So we had basically set up the same geometric arrangement of coils on a tiered series of tiers. Built a bunch of wooden, tiers. There was 3 different tier layers of wood that we built, with one in the middle, and then we did the whole geometry. This has been so long since I put it together, but we put bolts on. We did iron bolts, and then we wrapped them with coil wire, and then we wired them together just like the way that he had done in his diagram. And then we had set up to an alternating current power supply, and we pulsed it with a bunch of different frequencies at around.
Very important, just to kind of cut to the chase here. In Standeo's system, the entire idea of the Lorenzo is that you have 2 individual B fields that are both motional fields, and you have them crossing each other at 90 degrees. So that means you need a cylindrical coil, a solenoid type coil like you had around your bolt, but you also need a second coil around the base, that being wound around a washer or another toroidal coil. And in addition to that, you need to split that core so that you open up the inductance of that system so that it can have a very fast BH curve collapse when it's fed with a frequency. So you have to slice the cord, or the core, with a small slit just to break the magnetic flux. So what did you do for the second coil? Not the bolt, but the toroidal coil wrapped like a variac or something on those lines.
I think if I recall correctly, yes, there was a coil. So it was a piece of plywood that we used for the separation layer, and then there was a coil that was built on the bottom of the plywood as well. As I recall, this was 10 years ago, so it's been a while. But we wound a couple. It was like 5 windings on the small coil, and then like 20 windings on the top coil. I think that was the ratio that we used, as I recall. But we were interested in maybe. What are the ratios? Do you know anything about the ratios?
They should really be close to the balanced same amount of copper. Between the 2 coils, there should be roughly about the same amount of copper, the same amount of inductance.
And it's a split core thing.
It's a split core on the bottom. The cylindrical core, if you think about the solenoid coil with its center core, it's an open core. It's not a closed system, so it's not a closed loop. Its magnetic flux is free to exit its poles and project as far as it needs to in order to establish a magnetic path or a flux line. And the other core, well, if you close that, then you effectively cut it off from being capable of opening its system and interacting with the outside environment. So without the slice, you won't have some of the effects. Now, in the credit to people who had studied Standeo's original work on the very poor quality VHS tapes that are now broadcast on YouTube in various cut lengths, you can take a look at his diagrams, and he doesn't show the slice in the core. But if you ever buy his nice little flash drives and take a look at some of his more modern diagrams, which you can see on Google Images, he does show that slice in the core, and it turns out to actually be rather important. And in addition to that, even though he doesn't show the slice in the diagrams in these VHS tapes, he does talk about the importance of having this gap in the core where there's this archway, a loop over, where the magnetic flux is broken on the outside of the core. And this allows the system to become an open system.
So this technical stuff is like super boring to like so many people. Like, so how do you? Which is why I think it's like important that we have the patience. Not everyone has the patience to sit through and we're trying to like understand all this stuff. There's so much going on, and that's what trying to explain all this to people. And I'm trying to understand a lot of it myself. But at the same time too, because this is not an easy issue to understand. So. What was I going to say? There was a point I was trying to make with all this. And that was that we're basically, we basically have to throw a bunch of shit against the wall until something sticks, I guess. But if any of these guys, my whole thing is if any of these guys figured this out, then it would already be public knowledge by now, you know what I mean? like I looked at that Standio thing, and we tried it. We tried a couple different things. I guess I didn't really get into the. I wasn't as like hardcore into this 10 years ago as I am now. I will admit. And I've come a long way since then, and I've come a long way in the past year. And it's all about, educating ourselves and coming to, a deeper understanding of this stuff, really. But Mark, what are you working on over here?
I'm actually taking apart the gyroscope system because it was a bit of a failure structurally. I do think I saw some movement going on there, so I'm going to rebuild it. We got some.
Are you going to do it right now, just right now on the fly? Because
no,
like
it's
I
not
want
gonna
to.
happen on the fly.
Because this is.
Take several days.
Yeah, then let's set aside. Can we get another experiment in here? I want to
Oh,
show
yeah,
off some more
yeah,
equipment
we
and
wanna get
talk
the,
about some more stuff, because I want to get that klystron in here and maybe like show that off. And
Well, I think it's going to be pretty freaking cool. I could bring that in
I don't know about powering it up. We have to point it away from these cameras because that thing's like such high powered. It will fry
It's
cameras. It will fry
it's only
equipment.
as powerful. It's actually only as powerful as what you put in it. It's basically just a switch, but it's capable of controlling very large amounts of energy, which we have available with these capacitors over here, which we have not fired up yet. And I'm not sure if we want to fire them up right now. They are pretty freaking powerful, but maybe we'll do a low voltage version of that, 10 kV. What do you say, Jeremiah?
It's a possibility.
So-
we're still freaking out about it a little bit. We're a little bit worried because these capacitors are very powerful. They need to be attached in parallel for it to work. But that's a good suggestion. I'm going to put this aside and we'll start working on the high power stuff.
This is what I love about this is like we're getting so many people who know this stuff inside and out. We're really getting like key on specifics and actually running these experiments and doing them like to a T. But I want to talk a little bit more about my friend there and the old Standio experiments that we had done. We were trying to set up a TV show just to do a bunch of these experiments and stuff, and it really wasn't the right. We didn't have the right team back then, and it wouldn't have come together the way this is coming together now, with the team we have set up now. And even though we don't agree on everything, we fight, and we get in these arguments and stuff. Man, it's all in good fun, and I want people to understand that that nobody's perfect, and anyone who pretends to be behind a perfectly edited, pre-scripted video and stuff, and a whole crew of media editors and script writers and content producers. That's not reality. And even reality TV, like those reality TV shows that you work, that's not reality. That's not reality either. That's all edited. It's all like after scripted, and no, it's not scripted. It's they're taking real information that's kind of like from reality off the fly. It's all being edited and converted, and then all behind the scenes they're like, you need to pump up this relationship's getting a lot of reviews, so like you need to pump up this a certain aspect of it's all fake, people. It's all so fake, and like I don't care. I'm wearing a stupid bandana that's bright green. It doesn't match. It doesn't color coordinate. I don't care about that stuff here on this channel. We fuck up our audio almost routinely. Everyone jokes around about how bad the audio is on most of the streams, and how I always have you just have to fast forward almost to past the first 10 minutes usually, because I have to sit there and wait until I get the attention of the comments before I realize that my audio is not working, and then it gets me that 5 minutes to get it fixed, and then all of a sudden, so yeah, that goes on, but it's really
It's a one-man team.
It's a one-man team, bro. I'm doing this by myself, and I hired a noob who didn't know really anything about this to come and help me, and then he bailed on me and wasn't here today. So I'm pretty much doing it by myself, and it would be awesome if I had some guy that was if I had a media division, an entertainment division, if I was like Tom DeLonge, this millionaire rock star with born into it. I don't know how you get to be that famous and rich, and that you didn't have to work for anything in your life. It probably was all just handed to you. You didn't ever have to struggle or suffer or I just think of how many kids out there that are brilliant geniuses that could have been the best scientists, that could have been the Michael Jordan of whatever. They could have been the all-star of whatever, but they died in poverty instead. or they got into, because of their poverty, because of their living situation and the circumstances they were introduced to, they used their intellect and their strong wills and their strong motivations towards the wrong things. And that's back to what I was saying about Elon Musk and hiring people that don't necessarily have the best education, don't present themselves as like these we're not here presenting ourselves as like the best of the best, and we know everything. Hey, I'm Dr. Hal Putoff on earthtech.org, and we've already tried cold fusion and let me tell you, and all these other things in here. Just trust my website, and we know what all this is about, and everything here. And we are TTSA. We're like these, we've held contracts with the DoD, and you need to, believe everything we say and trust everything we say. And then like you go to earthtech.org, and their cold fusion page has none of the information that I uncovered with all my stuff on Peter Hagelstein and my trip to MIT in 2011, where I filmed the whole open course software conference. Not the open course software, the whole open course public course. I forget what it was called, but I went there in 2011, and I also went back there and filmed the cold fusion colloquium. And all Hal Putoff says on his page is that, we need to develop better calorimetry to measure heat. As if that's what cold fusion's all about, bro. It's so much deeper. There's so much more reality going on out there, and everything you find on the internet is such bullshit, and everything goes so much deeper than what you'll find in the first 10 search results on Google. And what you think you know about stuff is so limited to what is actually fucking going on, people. It's crazy that people don't see it, and like you haven't done the research. And I'm starting to realize this more, because I don't hardly ever watch my live stream repeats. It's usually just me getting on a mic and doing an information dump, because that's all I do is do research all fucking day. I'm up at 5:30 every morning, and I do research constantly, and I talk to everyone I can that can share information with me, and I shun the people that share bad information or that I catch lying and that aren't reliable or legitimate sources, and I tend to go towards the people that give me actionable scientific learning, real knowledge, and I know that it's real, because it correlates. What is truth? Truth is a chord. It accords to everything else that is out there that I believe is true, and that you find other information. So other people find truth in accord because they get all this other bullshit, and then they find other bullshitters who are repeating the bullshit or copycatters of the bullshit, and they say, "Oh, this is my truth because it all accords." It's all according to all these people, and everything accords because all these people are saying the same thing. It's crazy, man. And like this is how science and belief structures get stuck in these paradigms, and they don't get out, and they don't go other places. They don't build things. They don't like. They say like this kind of gravity research doesn't exist, or that it should be shunned. Yet this governments are spending, governments and aerospace companies spent millions of dollars investing in a lot of this stuff and building a lot of this stuff in their own laboratories. Why? Because what if it did work? What if it did work? What if it really does work? And it's crazy that this is how it's gone on for 70 years now. That the scientists who come forward with these ideas like Alzafon, going to Boeing and then them saying this is going to be classified 2 points higher than the Manhattan Project, and that you don't even have the security clearance to work on your own technology, and then they tell them that it doesn't work and that it's a bunch of bullshit, and then meanwhile they cancel all the studies, but then they hire a bunch of other graduate students who are bright and under their thumb, and they say, hey, listen, we'll give you some stuff that you can research, and then they hire these new people with security clearances to work on the stuff because they can be trusted with the secrets better. It's all about the secrecy and keeping track of the information through secrecy, and that's how it's always been, even with the Atomic Energy Commission and the Atomic Energy Agency with the Manhattan Project. It was all about they were trying so hard to keep track of all these secrets, and look what good it got us. Like that was a different story in 1945. What we were doing there and the war we were fighting. But the world's changed since then. We've been through the whole threat of nuclear annihilation and mutually assured destruction that happened in the 60s and the Cold War. And I think that all the countries of the world kind of realize that, you know, we've had nuclear weapons, and, you know, we're not going to just, you know, blow each other all up, because no one would win, and it would just be a lose-lose for both of us, and it's not really the way to get through this. But really, it was about building economies and building war machines and building and money, and this just blind quest for money, no matter where that money came from, and that the production of the science was all focused on producing money and results that would, you know, make money and fund war and all this other stuff. So we all know what happened there. I mean, not all of us, but anyways, moving along, we're past World War II. This technology is not going to. It's not crazy. It's not like we're gonna. You know, people are so afraid of like this technology. Look, we haven't. You know, like, it's not that easy to produce. If it was, we'd already have figured it out. And you know, I'm still waiting on these guys. Maybe in 2021 we will figure it out. Maybe we'll figure it out tonight. Maybe we'll figure it out in 10 minutes. Stay tuned, because you never know. We got a $50 live chat over here. Let me go over. Let me go over here.
She's actually calmed down quite a bit.
The CBD's working, and the dog's all calm now. Let me see what we got here for cameras and stuff.
Gyroscope machine was tearing itself apart. I was just afraid that one of the wires would fall off.
In any case, let me transition this again. Boom, there we go. Let me find the live chat over here. What's up, guys? Oh my God, there's so many people here. There was 156. There's 158. Anyone just tuning in? Guys, we are live in the studio here trying to replicate some anti-gravity experiments. No results so far. No, you know, it's crazy because you get these stories like John Searle, who said in 1950, you know, he was building this shit in his garage, and all of a sudden the thing just took off, and when he got the effect working, it happened so fast and so suddenly and so violently that the thing took off and put a hole in the friggin' ceiling of his garage. And he's gotten millions of dollars out of investors with this story. Nothing more than a story. You know, no evidence and nothing to show for it. It's like, come on, man. I don't know. Where's the proof, man? Like, what? Like, we're sitting here on a torsion pendulum, being like, oh, did it move? Did it spin a little bit? I think it just spun a little bit. Oh, that's awesome. I think we're getting some propulsion. When it should be flying through the friggin' roof, it should be giving it a punch, man. Like, if we're really doing it right, like, how am I going to lift my craft with this? How am I going to build a UFO which outperforms most, you know, military aircraft? Now we're building yeah, it's exactly a flying saucer. UFO is right. UFO is unidentified. Flying saucer is the better term for what we are trying to build here. At least try to, you know, it's a Gravitics lab, so we're not trying to build a flying saucer. You know, like, that's what TTSA. I was like, this is a joke. When they came out 4 years ago, and they showed that picture of that craft, and they're like, yo, we're gonna build a flying saucer. I'm like, you don't even have a Gravitics lab. You're not even, like, you haven't even done a proof of concept. You're just jumping straight to, you know, like, you know, you're jumping from crawling to running. You know, you haven't even walked or done any of the steps in between. So, in any case, you got to start somewhere, and this is where we're at. You guys just gonna wait till I get some time to sit down and really produce some well thought out, well scripted, well written stuff, because that's where I really shine. Is I have time to sit there and work on something, and really put it all together. These live lab experiments are good fun, and good for the people that are real hardcore followers of this channel. But I really want to branch out this information and get more of the general public interested and knowledgeable and brought up to speed with this stuff, and get some really short, well scripted, well explained videos done that can really break this stuff down for people. And in a way that's more accessible for the layman to wrap their heads around and kind of get what's going on, because this is really exciting, really cool stuff, man, and more people should be interested and excited in this about this, because it's like the Wright brothers inventing the airplane, but with Wi-Fi and cameras on the internet, you know, in the back of a friggin' shop in New Jersey. Hutchison's style is more controllable. I don't know, man. We have all the equipment. We got some killer power supplies and stuff, man. We should be able to do some Hutchison. I can't wait. We're gonna build some crazy Tesla coils and try that Philadelphia experiment, all that shit. We're gonna build we should build like a small steel ship and put three Tesla coils on it and like try to get it to disappear and teleport. Right?
He says this after dissing John Quincy Sinclair. You want to talk about weird warp fields and various strange things like that. The metals and their BH curves of John Quincy Sinclair's patent for his warp field generator. Very interesting stuff there. So he utilizes the effect of a particular metal that's made by, I think, Magnetics Inc. And in that metal, the BH curve for most materials, when you begin to input some magnetic flux, it'll saturate to a certain point, and all of a sudden you'll have a really sharp response where it just can't saturate anymore, and you continue to input current, but you don't get more flux out of that core. And then at a certain point it'll spike again, and you'll begin to get more flux out of it again. So in the metal that he used in his patent, and he does specify what that is, you end up with this BH curve which becomes very, very sharp at both its transition points, which means the emission of a sudden magnetic flux with a fairly steady sinusoidal input. And it's not that far off from many of these other things. It's worth looking into because the materials are stated there and they're available. You just have to buy them in quantity, and the companies don't really like to sell to individuals or hobbyists, especially not garage tinkerers without a major corporate license. That's been the major barrier to entry. It's not even a financial thing. It's just that they're not interested in working with individuals who are not going to buy a large amount of product from them.
Well, there you have it. Interesting stuff. Anyways, guys, I wanted to give you... Are we doing any more experiments tonight? We're going to power up the Thyratron. Man, I can't figure out how to do a screen capture and like an audio play like I can do usually, because I wanted to put like a video on or something in the background so we could all go take a break. Or I can take a break anyways. I need to go step outside for some fresh air. Guys,
Can you freshen your air a little bit?
my freaking head.
Freshen my air a little bit for sure, dude. I need to purify it with fire.
What is going on? We got $177 in donations tonight, guys.
What should we blow up?
What should we blow up?
Whoever donates the next $20 donation gets to decide. I mean,
Yeah.
what are the options really?
Next donation over $20 or over gets to decide what we blow up.
It has to be something here in the lab, like we could blow up a. I think we have some beer bottles. Empty
And it
beer
has to
bottles.
cost, and it has to be like, you know, like inexpensive. I can't like blow up the. Let's blow up the oscilloscope.
Oh fuck that! No.
Let's do it. This thing cost $100,000. This would cost as much as a house would back in the day. Like, this would have cost like $100,000 brand new in like 1980. But we got it from Singapore, and friggin' for how much?
It was $2,000 including shipping, and it actually is so old it uses these floppy drives. So
Oh yeah, remember
in
these?
the past, yeah, look at these. You got to be like 30 years old or older to actually even know what this
Yeah,
is.
the 35-plus-year-olds will appreciate that right here. Yeah.
Plug that in, and it connects with the USB to our computer. That's in order to get the
That's
information
it.
off of the.
That's the data, man. It's it can't. It's got to be.
Coming out on, moving out on a floppy.
So is it not compatible with newer data acquisition devices? Is that
It's the same data. It's just it's a lot cheaper device. I mean, we don't.
how is it USB? Oh, so it's floppy. You don't have USB out.
Yeah.
That's crazy.
But actually, Jeremiah mentioned for some experiments, this might be preferential over having digital output because there may be some noise source that wouldn't occur with the floppy drives.
Always something.
I've been back at home with a good old-fashioned TDS 3000 series digital oscilloscope, which I freaking love that thing, man. The TDS 3000 series. Yeah, the TDS 3000 series Tektronix scopes are great. If you get the advanced triggering module with them, they work quite well. And the one I have is 500 megs, but it's got a floppy drive, and well, I don't have a problem with it because it's what I've been using for a while, and I would love to upgrade at some point. But hey, there's nothing wrong with floppy disk technology. It's consistent and it works as long as you don't leave it sit around too long or expose it to magnetic fields.
Okay, so let's get this experiment fired up. Who's excited? Who's excited to see some exploding shit? We're gonna use this Thyrotron over here. Can we get the camera in on the Thyrotron? Let's show what we're talking about over here. So, a Thyrotron is basically a high voltage switch. I've shown this on the channel before, but this is the first time we actually have it hooked up. This is the enclosure I built for it. It's more than just an enclosure. It's actually all the electronics that necessary to run and trigger this device. We got DC to DC converters, buck converters, resistors, a whole gamut of electronics, and it's all powered off of this little, controlled via this little chip over here, which runs off of a laser light. So we're going to shine a laser through that hole in the side, and that will tell the tube to trigger its voltage. The energy is coming from these capacitors, this bank of 3 capacitors, and it's actually coming from the power supply, but these capacitors have enough energy in them to blow some shit up. So we'll see what happens as we power this up. The tube is powered by one of these massive lithium batteries, and we're going to hook it up right now and let it warm up until it's ready. Here, Jeremiah, you can take the stick.
All right. Sam Zurich, the troll, says, haha, this guy is just drunk enough to form a sentence. I love it, man. Hey, in typical Zephram Cochrane style. Tell you one thing. When Solar Broom hits and your computer dies, floppies will... Oh, yeah, the old style floppies, man. Yeah, those floppies will still work. The old ones. This one guy mentioned, remember the old 5.5-inch floppies, not the 3.5-inch or whatever they are, the old... the
SD
big
cards. SD cards, in terms of resilience to electromagnetic fields from an external source, SD cards are fairly compact and they offer the best resiliency, especially micro SD, even above that of floppies.
Right, yeah, so yeah, definitely SD cards are definitely better long-term data storage than even those floppies. This is like the skunk works, bro, but with the real skunk.
Smells like skunk.
It's not that kind of skunk works. Guys, pass the stick. Someone needs to... Oh yeah, I keep forgetting when I do this to put it up in people's face and stuff. So let me just see here. I'm trying to read this. Oh yeah, the squeaky toy in the background. That's the dog trying to get me to play with her. The dog's obsessed with me. Oh, she doesn't like being on camera.
Okay, what should we blow up?
Yeah, let's blow some shit up, guy.
Oh man, you can't blow anything through that Gyroscope.
What?
You can't blow anything through that Gyroscope unless you're talking really thin gauge wire. Here's what I would do for safety's sake.
Whoa.
Not kill your Gyroscope. we need some thin wire. And we're about to find it by stripping some stranded wire. That cheap garbage steel core wire that you have with the copper clad. Let's strip back the jacket of about 6 to 8 inches of that stuff and take one strand. That way we can test the output of the Thyratron without significantly causing extra heating issues, plate conduction issues, or other problematic things that we're going to see with this system. The Thyratron only has a maximum current throughput, so it's not like we can just dead short this thing across a huge bank of capacitors and expect it to be okay. So if we are going to try and fry a piece of wire and turn it into effectively a fine metal powder, we need to make sure that wire is thin enough to not damage our quite one-of-a-kind tube. Well, a few-of-a-kind tube.
This is a 31 gauge.
Perfect. That's a nice safe gauge to start with. Thinner than the conduction current of the electrons being emitted off the cathode going to your plate. At this voltage, you don't even need to bother stripping the ends. Just twist them around sufficiently and we should be good to go. Alright, someone's going to take the stick and I'm going to get the power here.
Jeremy, can you grab the stick?
Grabbing the stick. Jesus. Yes, guys, everyone's grabbing the stick. Humorous relief.
Pass the stick around.
Pass the stick around, guys. It's a party. It's that kind of party. Yeah, man, I'm trying to make it funny because, you know, it is kind of like a little bit of boring waiting time in between while we set up experiments and stuff sometimes. So I try to make it as entertaining as possible in the meantime. So, yeah, next $20 donation, I'll grab your stick. Okay? So, yeah. I said that the next person who does donate $20, we will just grab your stick. So go ahead and reach out.
So who's taking what now? I don't think I accepted this deal.
He said you'd grab a stick. Can we get like $20? Maybe like some more. Yeah, like send me some more money so I can you can fund the clown show. Dude, I'll just keep making it more of a clown show and more funny. You gotta have fun with this, dude. This is like, you know, it's a lot of boring hard work trying to recreate anti-gravity experiments that have already been tried. You know, so maybe these guys are a bunch of clowns, and I am wasting my time here, but no, I don't think so. I don't think so.
I'm definitely a clown. That's 100% for sure. Yes, we are a bunch of clowns. We are clowns that are trying our damnedest to actually test this stuff.
Well, how about this, Mr. Clown? What is your life? What if you just live in a simulation? Huh? What if it's all just a simulation? It's just all a simulated reality, a simulated universe. I mean, look in the long run, really, none of this is ever going to matter. It's all going to get sucked into a black hole, and every memory of your existence in time is actually going to be nothing. So, yeah, what are you here for? What are you doing with your life? Obviously, I've realized it. I've looked at the simulation. I said, oh, no. Even if it is a simulation, then my goal here on this planet is to make this friggin' transition happen for this pitiful species called humanity. I mean, I love humanity. God, I am humanity. But, God, we're pitiful. God, we need so much help. I mean, look at you in the comments. This is your goddamn sole purpose on this entire simulation and this entire planet right now is to help this poor, pitiful species get off this rock and make the next step. What's the next step? This is the most pivotal step in all of humanity. We're probably going to die in a pool of our own feces, like a bacteria that, you know, is too unintelligent to realize its own demise and evolve a faster way and a better way to get out of its, you know, death trap. So, I mean, realistically, you know, what are you? If I'm a clown, what the hell are you in this simulation? God damn it.
Okay, should we turn off the lights for this? I have the trigger ready. Okay. Okay, we're going to blow up a wire on the Thyrotron. Basically, the Thyrotron's a high voltage switch, and we're going to power up these capacitors, and we're going to insert all that energy into that super thin 31 gauge wire. There should be a bit of an explosion here.
Correction, we're going to try.
We're going to try.
We are going to try.
Rise a wire.
You want to shut the
Let's shut some of the light.
Whoa! I just fucked your camera up.
Oh, I did. I think I did that.
No, I did it. I hit it with my foot. So let's.
You have your laser ready. Give me a trigger test.
Hold on. I want to get this other camera involved here. You guys talk into this mic.
Just hold on. You're going to get 5. Pinky needs to get in the corner there. She's fine over there. She needs to stay behind Jeremy. Somebody's got to... I'm shutting this down if I see her run out. But you got to keep in mind...
It's not working. The switch isn't working.
Well, that's going to be a problem.
Did you charge down?
It's coming down.
All right, a Thyrotron. This is the Thyrotron. We in one of the other streams, I think we accidentally called it a
that
Klystron.
was cool as heck. That was right away a success. Okay, let's...
Well, 1 second. It's not ready yet. I have to reposition the...
So explain what just happened for people. Let's explain what's going on and what's happening for people that are.
It just fired and it actually worked. We had it at a very, very low voltage and it snapped right through. That was excellent.
Hold up, let me see here.
What's the position of the sensor, Mark? Is it aligned with the hole?
So what's going on in there? Why don't you explain a little bit of this gear?
This is the electronics that runs the Thyrotron. We need 6.3 volts at 20 amps roughly in order to power the tube. You can see the tube is glowing red right now. That's for the thermionic emission. The rest of the controls over here are for triggering the grid voltage, and we have a light that comes in from the side over here. You can see that it's hitting the photosensitive sensor over there, and that's what triggers the tube to go on and off. And as I trigger it, focus on the bulb on the Thyrotron for a second. Look, when I trigger it, you can see that glow.
Yeah, you see the glow as soon as he triggers that.
That's when the switch is complete.
He hits the switch, and that starts glowing. And what is that glow? What is that going on? That's plasma, right?
Yeah, it's basically thermionic emission of
Yeah, you're
plasma.
looking at electrons. What you're really looking at is a huge number of electrons being emitted off the hot cathode that's glowing and hitting the anode, which is the external lead connected to this point. So these electrons are flying off as soon as he gives it that light. And that's because it's receiving, it's not actually receiving a high voltage. What's happening is it has a high voltage on it already. And what's going on when he hits that switch is it's cutting off the positive side of that high voltage, which is shorting off the electron path, and it's also cutting off the negative side of one of those high voltages, which is preventing the electrons from getting back through the grid, which is the effective gate. If you consider this device like a MOSFET, in the grid number 1, that's the gate of the MOSFET. And grid number 2 is just a bias, so you need to provide it with some kind of bias in order to guarantee the electrons, once they get past grid number 1, can get through grid number 2, become accelerated, and hit the anode, which is this outer screen that we're seeing here. So all this stuff here, this is all the anode. And this gets conducted through this mesh that we see overhead to this output wire here. So electrons flow from the cathode through the plasma to the anode and out this wire, conducting eventually into this very thin piece of wire. And if the current is high enough, this piece of wire, it will not blow because it gets too hot. There's not enough current in this circuit to actually blow this wire from heat because of the short duration of the impulse. But what will happen is so many electrons will try to get through this wire and through this thin piece of conductor that the electrons themselves, because they are pushing away electrically from each other, they will cause this wire to physically rip itself apart and turn into a vapor, and that's what causes the wire to explode if this system works, if this tube can conduct enough current. It's not a heat thing, it's actually an electric field thing that blows the wire to pieces. So an interesting observation, and we'll see if we can get it to do exactly that in just a minute here. So we're ready to power up. If you
One more question. It looks like there's a couple different wire leads coming into this unit here.
Yes,
from
quite a
the
few.
thing.
You're looking at several paralleled leads in order to increase the conduction through, because there's it's much easier to work with individual leads from each of these pins. But yeah, several of these are paralleled. If you take a look at the outside of the anode, you'll see that on both sides, the top and bottom, you see two different leads there from opposite sides. Those two are paralleled, and they go up to pins that are coupled. If you take a look at some of your grids, you'll see paralleled leads. So in this case, you just have a lot of conductors because you can't send enough current through just one or two. So even on the other side of this tube in here, you see this cross connecting bar. So these are again a set of parallel leads with a bit of inductance in that system.
It looks like the two in the very middle. In the very middle, that middle pin, it looks like a common ground or something, and then the ones on either side of that middle pin look like the heating element for that core, and that's heating this in the middle.
That's correct. The two that are immediately outside the very center pin, those are the heated cathode. And I'm trying to remember in this tube. I don't remember if this tube is a directly heated cathode or if it's an indirectly heated cathode.
It's a heated cathode.
It looks directly. It's directly. This is definitely directly.
We tried wiring it otherwise, and it didn't work. You have to wire it directly into the cathode. That's where the capacitors are attached.
Before we lose too much battery energy, let's
fire it up.
Let's do a test trigger. Let's trigger this thing and make sure that it's actually responding. I see that it's partially triggering already. I'm seeing some flickering and electron emission, which should not be happening right now.
That was from me earlier. Just fire it up. Let's just go.
Well, I mean, hit it and hear it really.
Yeah, it's firing. Okay, just read out the voltage to me, and what do you say you got? 10 kV or 15 kV?
Just stand by. I'm going to bring you up to a lower voltage. Just wait for it. I want you to trigger it now because we're not at any current, and we need to make sure it fires before we bring it up higher. Okay, that was good. That was good. A nice hot snap. I'm going to bring you up. We're approaching 12.5 kV.
Okay, what do you think is going to happen now?
I need you guys to keep in mind that this thing could falsely trigger at any point, so this wire may just blow at a moment's notice. We know that it false triggers at 22 kV.
Okay, we're ready.
We're going to bring it up to 15 kV, okay? Oh. My power supply is tripped out and I can't develop any voltage, and we are in CC overload. I have to reset.
Eric, do you want to take the talking stick?
Try to trigger it.
Yeah, I do.
Here.
I hope that we were.
We're already at almost 22 kV.
Oh wow.
25 kV.
Oh, we burned through it.
We have to turn this down. Okay, now, at this point, that is a deadly assembly. So we'll wait a little while for it to cool itself down.
It was the purple flashes were much bigger when we actually had current running through it.
Oh man.
Coming down to about 3 kV.
These capacitors really
Very slow.
they really hold the punch, huh?
Yeah, and we don't have the voltage divider in parallel with it, so it's discharging to its own internal resistance.
You can shut off the heat fan.
Is it loud?
Yeah, you can hear it.
This?
Yeah. Or the one below it too also works.
Okay, that's pretty still approach it as if it's charged. You want to dead short the cap some more on the other side. Alright, good. Now if you really want to blow that wire, you're gonna have to use a stick. A stick and a lead. The good old-fashioned proven method of delivering a charge.
sparks going between the leads and the wire. Maybe we didn't have a perfect connection.
It doesn't need one. Trust me. If the current was sufficient, that wire would have blown to pieces.
Okay, so where do we take this from here?
Get that thing off the top.
It's heating up. It's small.
Oh,
Oh,
it's quite warm. Yeah, it does draw quite a bit of current.
Which is why we have this massive battery for it. Oh, even the battery got a little bit warm. Look at the size of this battery. It's 20,000 milliamp hours.
My guess is the resistors, yeah, they're quite warm. And your high voltage transformer in this thing. Let's see.
Oh, it's hot.
It's probably drawing a lot of current.
6.5 amps per circuit. Enclosed box. She can only run for so long. Alright, let's clear it up. Discharge the caps directly and use a broom handle to discharge it. Who's got a broom handle? Let's get a piece of wood.
Exciting stuff.
So very... Alright, let's attach a piece of wire to a piece of wire. Now what we need to do is stretch that piece of wire between two bolts, attach one of these output wires to one of those bolts, and let the other output wire be attached to this stick, which we bring close to the second bolt.
This is already attached to the output on this side.
Oh.
I can just move it out of the way for now.
You could also disconnect it.
Well, I would have to take the entire center.
Alright, well then, just move it out of the way for now. Go ahead, right up underneath. Prop that up off of there too. Quite a ways.
I really.
I can disconnect it if you want. Should I open up that bolt? Disconnect it?
Probably a much smarter idea. I'd remove it out of circuit.
Let's take it out.
And I'm going to go put 2 bolts into a piece of wood. So that we can do this and actually show some sparks and arcs for people on the live stream.
Yes, guys. So those of you just tuning in, we did some experiments already earlier, just showing an update of everything we're working on. Kind of keeping a box of goals here to basically do replications of all these. We have a whole book of, master list of all the anti-gravity experiments that have been tried and all the different things that have been tried, and things that allegedly yielded positive results, and we're trying to replicate those and or to further study those positive results in our own Gravitics lab and try to expand on the understanding of the phenomena which is occurring to produce those anomalous results, and how to actually scale it up and build something that will work to produce a lot of thrust instead of just a little thrust. A little thrust would be a good, small victory, that could get funding to get future.
I'm okay with any thrust. Any thrust at all. I do not care what that number is. Any thrust. I'm down with it.
Sam Zurich from the live chat says that he is a big fan of thrust. Won't tell you what kind of thrust he likes, but
if he can thrust hard enough to get through space without propellant,
yes.
I do mean without propellant.
Yes. So if you can thrust
This kind of thrust involves a very specific type of propellant.
Well, he has to find a way to thrust so hard that he doesn't need that anymore.
that's fine. That's fine with you.
A Sam-powered drive, he might not like it.
Lots of people are into different types of thrust out there, and lots of people have different ideas about thrust. But in this laboratory, we need to
All
really
I can say is be careful what you wish for.
we need to be really focused on just what kind of thrust actually works. If it works to get the job done, it's all we care about, really. And we don't discriminate, because if it works, then it works. And if it works for you, it works for me. And if it works in your laboratory, it should work in my laboratory, right?
That's the idea of repeatability.
So bring your thrust on down and demonstrate it. And if you can show off your thrust, and your thrust is really better than our thrust, then fucking bring it down. And I want to see the game. Let's go. If your thrust is harder and has more force than our thrust, then you can produce more thrust in your laboratories, like at Skunkworks. You know? Come on. Bring it on out. Bring it on down. I want to see the...
Sure, that's what they're doing at Skunk Works, producing thrust.
It's hilarious, man. I love it. Why? Oh, look at Sam Zurich. He said let's get gay, dude. I said nothing about getting gay, dude. This is about thrust. What are you talking about? You just showed your true colors, man. To the whole group. Sorry, man. That's all right. Hey, man, you do your own thing. We all do our own thing here, and no, we don't discriminate. You want to come down and show off that kind of thrust, then you can. But
It better be
oh,
a good
man.
show, though. Don't want no cheapskate show.
This is fun, man. I like trolling the trolls, man. That's what they come here from, man. You want to heckle me? I'll heckle you right back, bro. What do you come here for? Why are you here in the simulation? Are you trying to get humanity off the planet, or are you just trying to like?
He comes for the thrust. He comes for the thrust.
Yes, he definitely comes here for the thrust. I didn't say it, but well, I did. I repeated it. That's a lie. I repeated it directly. That's a lie. I think I got COVID, man. Just kidding, Travis. You bastard. Travis stayed home and I didn't go pick him up because he thought he caught COVID he might have caught COVID over Christmas because of people he came in contact with. So that's why he couldn't be here to run our audio and our professional video and everything. So just in case people were wondering what happened earlier and some of the aggression.
UFO beer.
Oh, we got some beers coming out. So we want to talk about. It is time.
You have to open those, I think.
So in pure recipe for success here tonight is to finally bring out the alcohol, which people out there have a really hard time believing that we're not already drunk. But the fact is, we are not. And
But it's plenty of time to enjoy ourselves.
so, for those of you sitting home Sunday night and have to go to work tomorrow, we're sorry. This beer is for you. And by the way, this isn't our day job. We have real day jobs, and we go to work, all of us. And you know, I don't know. I don't know if we get positive results here in the next couple months, or somehow this really takes off somehow. I don't know. You know, we got to do a lot more live streams. You know, $200 a day. If we do one live stream a day, $200 a day really ain't cutting it for me, man. That ain't paying my bills. And we got to divide $200 by 3 people. $200 a day might pay my bills if I, you know.
Pay your bills, pay my bills. I don't know, man. I do this because I love it. I've been doing it for 21 years.
Well, that's the thing I was describing. I was trying to make this point before, right? And the point is that the people who are really into this, and the reason I'm teamed up with these individuals, and that we drink and we crack jokes and we have fun with it, is because none of y'all motherfuckers are doing anything more than sitting on your armchair. Like, I mean, some of y'all are. I'm not gonna lie. There are a bunch of people in the live chat here that watch this right now, that are watching live right now, that are doing experiments and engaging in this, and they're here for this. But the fact is that the people you meet, right? It doesn't matter how good they are, because I have plenty of people that I know from advanced colleges that have lots of like education that I could ask for about different things and get advice from and stuff. But for them to take time out of their schedule to come to the lab for free and do work like this for free, just because they're passionate about it, it's hard, because the best people you can find to work for you, the people that are passionate and really want to do this and really want to do that work, you know? Because let me tell you something. If you ever apply for a job somewhere, right? Those of you who are going to work, and those of you who don't have a jobs right now, because many of you sitting home watching this might not have a job right now, but I just want to say, like, if you ever want to apply somewhere, I want to tell you how to get hired. I'll tell you how to get hired anywhere right now, okay? Apply there, okay, first off. And when you get turned down, apply there again in 6 months. And when you get turned down again, apply there again in 6 months. Okay? You're going to get hired. Doesn't matter. Like if keep getting turned down, you keep applying every 6 months and you say, "No, dude, this is my dream job. I need this job. I can do this job. I want this job." Doesn't matter what the fuck is on your resume, bro. You applied, that's a fact. You will get that job. So right here, my job is to, I don't know what I'm doing here, but we're trying. My job is to try to show what the heck is going on in this lab. I'm here to collect some information. Of course, the live stream is just here for fun and for entertainment for our private guests. But I have been collecting a lot of media and information and stuff. We're going to be doing some shots of all these experiments in a much more serious fashion and running these much more boring experiments where we actually take data on this stuff and show it. But this is a real good way to take data and just show things off because we're doing the experiments live. I mean, this is data in a lot of ways. It is data. So if we do get something, we can go into more scientific detail about, we're pretty good about eliminating false positives.
Yeah, we've done that a lot tonight, and I think the most positive result we got today was with the gyroscope. So we saw some movement over there. It was pretty rickety. The setup wasn't secure enough, but hopefully we'll be able to rebuild that system and have it ready later in the week.
Well,
before the new year, and we'll get that thing working for real.
There's a real cool video I posted out. Yes, to science. To humanity.
Science for humanity.
Yes.
Absolutely.
Science for humanity.
UFO beer.
Wow, that's really good.
Orange peel and coriander.
Harpoon Brewery is not a sponsor, but they are awesome brewery. Thank you, UFO Beer. Thank you for supporting ufology, and if you are interested in, supporting us with free beer, we'd rather have money and equipment, science equipment.
But beer is always good.
Beer's good. It's I mean, we wouldn't have to spend any of our hard-earned money on beer. That would be good to get free beer, but I wouldn't want to make this all about beer, and not people think that this is about beer, and there's a lot of people that don't like beer and don't drink beer. But whatever. There's a lot of people that don't like AntiGravity, and they're not here.
They don't drink that either.
They don't drink that either. I don't know where I was going with that, but anyways,
I don't know. AntiGravity could be one of the best drinks ever in some galaxy far, far away. We don't know. We just don't know.
You just can't put it down.
It was in Willy Wonka, when they drank that bubble fizz soda and they floated at the ceiling, Come with me and you'll see a world of OSHA violations. Sorry. I had to mention that from last time. Last stream, people got it. But anyways, we got another $10 donation from someone that said, Sam Zurich is a troll. No, I'm sorry. That was not what they said. I gotta go find this guy's dominating the troll, man. It's funny. It is funny to laugh at the
super troll in the super chat.
Oh, it's funny, dude. He's great.
Guy is skilled then, eh?
He's good, man. We'll keep him around. We'll keep this dude around. He's educating everybody. He's so smart. Genius. Pure savant.
Absolutely.
Okay, VPXM, dude, more money. He just keeps giving me more money. Go feed that dog for VPXM, dude. Go freaking...
Where's the dog treats?
Where's the dog treats? Here's the CBD. There you go. There you go.
Hey, CBD dog treats, everyone. Pinky, come here. Oh yeah. We're giving you 2 of them because VPXM just keeps on giving us money. Pinky, come on.
I'm begging for money.
Pinky, come on. Pinky. Oh,
He said, hey, I'm not the one begging for money. Who's begging for money?
It's Pinky begging for treats. That's what it's really about.
Pinky is begging for treats. It's a dog begging for treats, dude.
How can you let down a dog begging for treats? The CBD treats, they're calming her down. I think she's gotten into a
Dude, it's a dog that every time someone gives a treat, we give the dog a donation. No one here is begging for money, dude.
Every time the dog gets a treat, we give somebody a donation.
Look,
I can't complain about any of this.
you can't be
I am,
begging for
quite
donations.
enjoying myself here for the good old times.
Yeah, I'm having a great time, dude. This is fun. We're learning so much about like these experiments for real, and
Quite frankly,
like,
this seems like a
you
stupid
know.
waste of time. But what
Yeah,
we're
it
about
is,
to find
like, you
out
know.
is whether or not two things are true. One, do these capacitors completely explode at 45 kV, their nameplate rated voltage? Or two, do they have sufficient discharge energy to effectively give us a threateningly high level of audio that we should be probably wearing earmuffs for when we discharge their full current via plasma arc discharge in mid-atmosphere through this piece of wire? That is the question of the hour. The answer is we should be wearing ear protection.
Okay, let's get the ear protection on. PPE box.
Yes. Plug your ears.
Oh, Jeremy, no.
These wires, Mark, are egregiously
Oh.
long.
Yeah.
These wires,
Oh.
Mark, are egregiously long. These are terrible. I'll use them, but ooh, I don't want to use these wires. Because here's the issue with these super, super long wires. There's going to be an electromagnetic pulse that's produced by those wires that's going to emit out into this room and around all these equipment and wires and everything else. So we should probably not use this giant long piece of cable and instead connect directly from this terminal or that terminal or any of these terminals directly to that point. Very much so. Yes, with a fairly thick conductor, very much like the one you used.
Yes, that was a great comment, and I'm going to play off that right now with some improv. We are reporting live here. I am Jeremy Riss, head of Trump's Space Force Research Laboratories. And Donald Trump himself will be here later today to give the stamp of approval on the experiment that we're about to conduct for you all. Right?
The black limos are showing up.
The black limos will be here, and Donald Trump himself said that this is the best idea ever because he thought of it, and that his scientists are really some of the best scientists you ever heard of and you've ever seen. And
They're so successful,
His
you're getting
scientists,
sick of.
specifically, as in ownership.
They're so successful, you'll become sick of their success.
yes,
Sick of winning.
yes. So I don't know. I don't know where else we can go with that one, but that was pretty fucking funny, dude. I thought that was great. Trump's Space Force, dude. We might as well be Trump's Space Force, dude. Nobody else is. Who the hell else is doing this? We need a serious, like the government should be having like a serious laboratory. The thing is that what's even more funny is that all your tax dollars already paid for all this research with like a whole bunch of real serious labs and real serious scientists, you know, who've worked their entire lives on some of the most amazing theories. And the problem is it's all classified. You can't have any of it. And I've basically spent half my life digging through these people's work to try and get bits and pieces of key information out to you people. And the thanks I get is what? Christ.
You get nothing. You get nothing, my friend. You get nothing.
You get nothing, you know? Roll another doobie, my friend.
No, but this is the one that I am standing next to, which means that is probably yours. I am scribbling on the computer right now.
Yeah, this is fun, but I you know, hey man, if I had a media maybe if we had like a media division like Tom DeLonge, like we could like, you know, sit there and like put well-produced videos together. But then like everything would be scripted. We can't like promote or say anything about positive or negative about anyone else. You know, never talk about any other researchers. You know, we're the only ones that ever existed, and you know, we'll never cite our sources or talk about any of the people. You know, we'll just be like, anyways, I don't want to talk about.
PVC over there. the PVC up by the gyroscope experiment or the yeah, it's either by the gyroscopes or the RC stuff. There's a box with all the little plastic parts.
All right. Any more questions over here in the live chat? I'm gonna see. Bow ties, yeah, dude. Would I have more credibility if I wore a bow tie? Like,
Yeah, dude, put on a bow tie because who wouldn't want to see that? Why not?
Dude.
Put on a bow tie.
that should be part of the costume. Like, I should just have a bow tie on in addition to all this. Like,
That's what I was telling you from the start. Why'd you leave your bow tie, man?
Yeah,
you left so much.
You've
shit
been on it the
line.
whole time. Absolutely, 100%, 150%, 1,000%.
this character
10,000%.
thing, man. You know, I'm
Who
trying
cares?
to play this mad scientist. You know, but I'm kind of like a renegade punk scientist. You know, outlaw scientist too. You know, like pirate kind of semi-scientist. You know, but not full pirate. I'm not just like straight up, robbing from people and pirating their shit. And I try to give sources and show people where they can get like information because
Somebody just donated $5 and he says you guys talk crap about everyone, but have yet to show any scientific proof. Well, we've shown you a lot of scientific proof about shit that doesn't work, and honestly, that's just as important as stuff that does work, because now you know what not to do.
Who can complain about a troll that donated $5? That's what I'm saying. Thank you.
Yeah,
Thank you. Thank you.
I'll
I'm not complaining. Look, I'm just going to
Dude,
continue to do exactly what
I'm
I'm doing
gonna
right now.
Yes, which is talk crap about everyone because hey, you can throw shit against the wall until something sticks, right? If what I'm saying isn't true, right, I can throw as much shit as I want, right? Because nothing will stick. Because to the truth,
It's the squirrel test.
the truth it's the squirrel test. It's the squirrel test. Tell us about the squirrel test.
I don't think I should probably tell you about the squirrel test. I think
you should tell us.
I think everyone here no, I don't know, man. I don't know. Maybe not. This is kind of like inappropriate, really inappropriate engineering talk, and some people might really seriously take offense to this. I don't know if we should really talk about the squirrel test.
probably not.
Well, let me see what people think in the live chat.
I'll talk about the squirrel test.
Do people
for
want to know what the
$30
squirrel
donation.
test is?
For $30 donation, I'll tell you the old electrician's joke of the squirrel test.
Oh shit, Carl Christofferson. I looked up to you. This isn't good. I like to relax having a beer but not on a stream. I have followed you for years, but I do not think I'm going to. So this guy just donated $50, and Carl, I've seen him before, man. He's been a long time older.
Listening to Carl's advice and what he thinks.
About
because he's probably
drinking
got
beer.
good info.
VPXM said, very good answer. LOL.
Very good answer, LOL. Yes, thank you. But I've talked about this, and I thought about this about like the thing is like I can't do this by myself, dude. I don't have like all the media skills to sit here and film all this stuff and do it. So like I try to set it up like this so we can show it all off at once, and I try to have fun with it. It's very stressful, and yeah, and I know having a beer on the stream kind of like distracts from the situation and stuff. But, Joe Rogan smokes weed on his streams, and he takes shots live on his streams. And they call it apple juice, right? But that I don't know. That gains attention in both directions. I understand what you're saying, Chris, and I appreciate the input and what you have to say about that. And I don't want to make it like I know it does. Some people are making it detract from the credibility. There have been jokes about it on Twitter about the alcohol that's been in the background on a couple of pictures and stuff. And
I've been to many labs and seen lots of alcohol. I've been to NASA labs and there was people that were drinking there. They don't do it in the lab. They have it on the side, but it's not.
Thing is,
The question is, how many big labs have any of these audience members realistically
the problem
seen?
is that everyone's about fake shit. Everyone out there is so used to the fake, overproduced, television, version of reality that when they see like, real reality portrayed to them like this, it's shocking. It's just not. It's just outside the norm, and it's like, well, this isn't what I expect. This isn't what I envision. And that's what you envision is not reality, and what we're told and what's portrayed to you with of a lot of things is not reality. I know a lot of NASA scientists that smoke weed, You know, there's quite a few PhD NASA scientists that like to go home and relax with a beer or smoke weed. You know, there's people that they're probably working at NASA right now that are closet alcoholics or completely functional alcoholics that drink while they're at work and all day, and that's fine. You know, I'm okay with that as long as they're contributing and getting work done, and it's not like super impeding. Everyone has.
Solar Marshall. Who cares if you are drinking a few beers? Exactly.
Who cares, man? Like, I don't know. I understand what you're saying, that some people are going to use this to try to discredit us
let's
and,
put it
and
this
look
way.
at it.
Okay, this is a Sunday. We're not at work. This is not our full-time job.
No.
It's a Sunday. It's the weekend. Dude drove out from Rhode Island to join us in the lab so that we can do these experiments live for the first time on air. It's not our final version. It's not even close to a good data-based test. But the fact is that he came out and it's happening.
Dirty Bong says, try some DMT and ask the aliens directly. Well, I love that comment. I'm not going to comment on the comment, but there's a lot to talk about.
You really shouldn't. You really shouldn't. The
Yeah.
point is that this is our weekend. This is how we're hanging out. We're hanging out, and instead of just, sitting at home watching TV, all wasting our time, instead
Right.
we've decided to hang out together in the New Jersey lab. Nobody's paying us to do this. Nobody's paying us to be here. And we're sharing it with you guys. Because why? We want to show you basically what we're working on. We're showing you the crude versions of the stuff before anything happens. And
And don't
get
pay
a
any
chance to
mind.
see it,
Don't pay any mind to these trolls, dude. These people are like, guys. There's one guy that posted it. Man, he looks like he's lived in his parents' basement, and his mother's pampered him from his entire life. So you can't you can't listen to all those people either. It's not like we're this is humanity, and I like to be an honest. If we're gonna meet aliens and build a spacecraft and go to space and meet aliens, we're not gonna go and it's not gonna be the television, White House press secretary version of fucking what people think it's gonna be. These beings are gonna be way more advanced, way more intelligent, and they're gonna see right through all your lies and all of your bullshit.
Stephen
Okay?
Wilson just gave $50.
We need to be as an honest and straightforward representation of humanity as possible.
let's
And
ask Stephen what he wants.
Stephen, what do you want? Did you have a comment? Stephen Wisen, thank you for the live chat, man. Another $50. But I'm letting you know that right now that if you can't hide nothing from these beings. For all we know, they've had fucking cameras, filming everything we've done, and we're on a reality TV show for them in another galaxy. So, I wouldn't go too far with what you believe about you're talking about aliens and stuff and humanity, and trying to hide behind an image and trying to let's scuffle the beers off the scene so we can do a photo shoot, and let's hide this from the audience and pretend to be something we're not. No, that's not what we're about here at all. And if you're about that, then maybe you should go back to watching that other kind of stuff. I mean, it would be cool to have a video editor who can shorten this stuff down to some key segments so that people don't have to sit through all the monotonous bullshit and stuff. But I mean, honestly, I'm not a perfect human being. I don't claim to be. I've been through hell and back, and I've seen a lot of stuff in my life. And I think that everyone needs to kind of understand that all the evils and problems in this world before they can and really face those and talk about those evils before we can really confront the evil that we're going to face out there.
Well, let's
Once-
talk about
once
the
we take
reality
the
of what
next
we've
step.
done here. I mean, this room, 2.5 weeks ago, not even 2.5 weeks ago, this room was a bedroom.
Yes, it was completely, none of the stuff was here 2 weeks ago.
This room is now a fully functional laboratory with an organization system that is highly efficient and has allowed us to produce an incredible number of various experiments in a very, very short period of time.
On a very small amount of funding. Okay, if that's not showing off to serious people out there, like, oh my God, we gave NASA $500,000 to do the Podkletnov experiment, and you guys did it with what?
The superconductors were $1,000, and the Marx generator was another grand, so we're like $2,500.
And the rest of it is stuff we got or is scrapped from equipment and we're getting sent, And by the way,
Every dollar is basically stretched down to its maximum. We're finding used equipment. We're maximizing the use because there's nothing wrong with used equipment if you know how to use it. And the fact is that almost everything in this lab Especially today, as we found out, even the stock stuff has to be modified. Nothing comes out of the box good enough, especially not for the way that we're using it when we're trying to test unusual physics, looking for strange phenomena.
Yes. And we're also like builders and engineers, so it's like when you're looking for something to use to build something, sometimes the weirdest shit we'll do. And like dollar store turned out to be our best friend, because like we just go to dollar store and load up. Mark, tell us about like your experience with dollar store. I gotta go run and use the bathroom, but like just talk about some of the stuff, and then also ask people like what they can give for donations, like if they can put together like a box full of stuff, like whatever, like extra
Just
shit.
random
There's
equipment.
people that are cleaning out their garages and trying to get rid of stuff right now. They're home. What can they give? And like just because you mentioned a bunch of stuff from Dollar Tree. You just like, I don't know what I'll use this for, but it kind of looks useful, and I'll grab it. And then you end up running out of it. Talk about that a little bit. I'll be right back.
Oh yeah, so basically while we were setting up the lab, we just knew we needed a whole bunch of random stuff, and we have a dollar store next door. And I walked into the dollar store with the goal in mind was to spend at least $100 at the dollar store, because I knew there was a whole bunch of shit in there that I'm gonna need. And I'm grabbing all these like spatulas and different utensils and different types of metal plates and shit, and rope. And actually, we bought a ton of stuff and had to set it all up on the in these buckets over here. And since then, I've bought completely random stuff that I had no clue what we would use for, which we eventually ended up running out of. But it's great to have that great resource nearby. Another great thing that happened with Jeremy, he actually was searching on Craigslist for a lab that was going out of business, just like searching for, to buy cheap equipment. And he got us the 5,000 volt half amp power supply, which was a real find. Like, I don't even know any amount of money that could have bought that thing, because it's not on eBay. And to buy it new would have cost, an arm and a leg. But that is the power supply that we're using right now for the Klystron, which is for the high power Alzaphon, or dynamic nuclear orientation experiment. So it's really about equipment. It's here. It's not about just money. The money can only take you so far. There's certain things money can't buy, like that Thyratron tube you saw before was taken down from the Berkeley Labs linear accelerator. They just broke it down and sold all the parts for scrap and whatever. They sold them on eBay to tube collectors. I'm probably the only one who ever powered it up since it's been removed from the lab, from the Berkeley Labs linear accelerator. Oh, we just got another donation. What is?
I'd like to have a bear too, but it would help if you had a higher standard to not being dismissed that easy on a technical point.
Oh, I totally agree with that. I mean, we just got the beers because it was kind of cool. Yeah, all the experiments are done, with sound mind, and the experiments speak for themselves, because
This is our Sunday relaxation day off.
they don't
Sharing it with you guys.
they don't really
We're doing
care.
this every day.
They don't really care whether the experiments don't care whether you had a beer or not.
Yes, if it works, it works. But this isn't our daily ordeal. They gotta understand like that. This is my passion. This is like what I do with all my spare time. I don't live in an environment, in a world where I'm fortunate enough to be able to have universal basic income that just pays me to do this all day and do this kind of research and try to talk to scientists and bring disclosure out with all the best ideas and all this information. That a lot of this was suppressed, really hard to find. It would disappear off the internet when I first started researching this, and now it's like it's all out there. It's good, and more people are getting interested in researching it, and that's what we're trying to do here. That's all we're trying to do here. I'm not claiming to be anything. Not TTSA. I'm not claiming I'm like got the best in-sorters and the best sources, and that we're going to bring disclosure and all this stuff. I like to talk about it and joke around about it, because this is better disclosure than half these fake people out there are bringing. They're talking about all this nonsense, and in their witnesses that where are their sources? They're just each other, It's just a bunch of fake storytellers, and all their sources are each other. And I'm out here trying to do real science and bring some physics to this. My interest is in science and physics, and I'm trying to bring experiments into this so that we can if any of this shit's real, then we're gonna see it. And if it's not, then we can stop wasting our time on it. And hopefully other people can stop wasting their time on it. And if you're wasting your time being here, then go find something better to do. And We're having fun. This is not what yeah, exactly, Jeremiah. This is not what I do with my, for full-time job. I'm just here on a Sunday with my friends.
That you guys are included.
And thank you. We're just having fun, and I'm not. I don't know. Maybe I should reorganize or regroup at some point. And if that happens, maybe some will be. Maybe through this we'll meet the right connections and meet the right people that will be able to do this full time and become serious with this and have a laboratory where people pay us to do tests on other shit, because they could hire us to do tests on something, and and then I'll give you a price, outsource it to us, and then all of a sudden, boom, I can do what I want to do. I can do what I'm passionate about and what I love, and I can do it with my friends, and we can have fun with it, and
Argue about microphones.
we can argue about the microphone and the sound equipment that's always broken on every alien scientist stream, but people still here watching and still care, because it's about the information, and it's about the discussion. You know what I mean? So it's very key. So anyone that's been in a bad place in their life, I hope you guys get back on your feet. And that there's a lot of dark energy in this universe, and human potential and human imagination is infinite, okay? And that's the wave function, all right? And we live in a world where we all have to share this society together. And when you apply your wave function to try to create, hate and try to create the wrong things, you will see that bad things will happen to you. As bad things have happened to me, I'm sure bad things have happened to all of you when you have acted on those negative emotions and those negative feelings, And we all have, and we're all guilty of. We're all learning from that. I'm learning from it too, and I've burned a lot of bridges with people, and I've talked shit about so many people, and that's fine, because we're all on our own individual path, and we can't let we all have to just take our own individual path to get there, and just take. It's better. I'm learning more as I'm going on about taking a chill pill. And that realizing that intention is everything, and that in this simulation, in this simulated quantum universe, really whatever we want it to happen, whatever we envision will happen within in our world. And there's so much else going on in the world that we're not even aware of, that if it's not in your wave function and not in your realm, that you won't even be aware to it, you won't even be tuned into it, and it won't come into your reality. It won't exist to you. So these things exist. You have to understand your place. You can't just be completely lost in your dream reality and making whatever you want to believe. You have to work with the tools you have, but you have to understand the way where we are where humans are right now. We belong in space. We know that there's these. Everyone here should know that there's stuff flying around out there that we can't identify. It has been for years. There's stuff we can't explain. The Air Force knows it. The stuff that defies their capabilities and their understanding. They tried to keep it covered up for so many years, and they can't do it anymore with the internet. So they just have to deal with it and kind of come out with it. That's where we're at. And there's all these rumors about aerospace companies and government companies building anti-gravity and doing these experiments in secret. And there's all these conspiracy theories and ideas about that. And I want the fucking truth. I want the damn truth. And how we know the truth is to get in a lab like this, and this is what I talked about that we needed to do, is get a community lab, get a lab for vetting these experiments, get a discussion panel for really bringing out the scientists out of the woodwork and bringing these ideas out. Mark did an excellent job setting that up with APEC, and when he invited all the he basically. I hooked this kid up with the Estes Park Conference and the DARPA list and all the where to get all the real information, all the propulsion scientists and all these people. This dude straight up had the balls to straight up ask all these people to come to our conference and start his own conference. And they came, and they started coming. I couldn't believe it. And so this is like a real.
They were emailing me the other week asking why they didn't get a link to the latest conference.
Yes.
Well, it's because it didn't happen, because we took a week off.
Right. And now it's such a joke, but guess what? There's people climbing up and clamoring. We have so many guests. We're backed up. We're backed up for so long with people trying to get positions to speak on this conference now, man. We got so many friggin' people coming forward, and this is the gauntlet. This is great. This is where we invite all the trolls. We invite all the smartest most intelligent, people who think they're the smartest too, but we invite all the smartest physicists. This is the gauntlet, is like, of ideas. It's like, you come and present what you think is your truth and your reality, and then you stand up, and then we're just going to cut down all that. We're going to, go through all these things and really track down which one works and which one is the most promising. Try to pluck the lowest hanging fruit first, and then if we have to, reach towards, more advanced things as we exhaust other things, at least we'll know. And there won't be these speculations or these rumors or these claims of conspiracies or cover-ups, or the technology really worked, and that will all go bye-bye. Either experiment will be the arbitrator of competing hypotheses, and I think that's going to be awesome when we're able to show what works and what doesn't.
Okay, we're getting ready right now to blow up this wire, and this is going to be a straight up mechanical switch, and we'll charge up the capacitors to their full potential, and we'll see what kind of explosion we can get out of it. And we're just waiting for Jeremiah to come back into the lab, run the control on it. We've been here since I think since 7 in the morning. It's been a really long day here at the lab, and we're just showing you the last few bits of everything we've put together. A lot of this equipment has taken months, if not years, to get together, and this is the culmination of all that. There are a couple more experiments that we're very excited about. You saw the first prototypes of many of these iterations of these experiments. Just because they didn't produce the effects that we wanted, we did see some anomalous results, and we already working on stage 2, prototype B, for the various experiments. And when they're ready, we'll go live again and show you them again, because it's fail-forward research. Every mistake you learn from, and you just move forward with that, and take the machine apart, use the parts to build a better machine or better device that better replicates the experiment, so you understand exactly what it is where you failed, what went wrong. With the gyroscope machine, there's definitely not enough structural integrity. The pivot points need to be beefed up, and the servos just weren't strong enough. So we got better materials coming in tomorrow, and I hope to rebuild that machine and show you guys a real working gyroscopic linear propulsion device.
Yeah, but that's the whole process of engineering. It's like, you have to build that first prototype, and it's going to be fucking stupid looking. Look at the first helicopters. Look at the first airplanes, man. Those things.
What's going on with SpaceX right now?
Right. Everyone shows off that failure now, and it's like we laugh at it. It's like the fail blog. Yeah, and that's what you're looking at right now. You're laughing at it and looking at fail blog. It's like, yeah, okay, that's where we are. We're at that first Sikorsky, stage before Sikorsky had that breakthrough where he's like, oh, you just put this one rotor and then you have the other rear rotor on for stabilization, and that's the model that works and will take off. We're not even there yet. We're working on the propeller.
We're trying to prove that the propeller works.
Yes, and that there's other propulsion other than reactionless propulsion, that we don't need rockets. But the thing is, we need a lot of, in order to get to space, bro, we need lots of thrust. As we were talking about earlier, we're joking around about thrust, but reality is that we need lots of thrust. We
just got a super chat donation from this guy. He's asking about Podklanov's method legitimate. Okay, so the Podklanov has 2 famous experiments. One of them involves a spinning disk that just lowered the weight of a sample hung above it. That experiment is pretty difficult to work on, because he says there's a minimum size for the disk, and it needs to be spinning at a very high RPM, RPM changes. That has been tried by quite a few people, including Ning Lee down in Huntsville, Alabama, and there's some conspiracy about that. So we're not really concentrating on that spinning disk experiment. What we're concentrating on is the Podklanov impulse experiment, where they use a Marx generator to impulse a bilayer superconducting superconducting material inside of a strong magnetic field. That's supposed to create a gravity impulse, and that is something that we plan on replicating here at the lab. We do have superconductors, and we have lots of coils to make a very strong magnetic field, and we will replicate that in the coming weeks. So yeah, Podklonoff is way up on our list. We're very excited about that experiment because it's one of those things where like you should be way out of the noise with that experiment. He was claiming that they were getting holes punched through cement. So like I don't even know if you need a gauge to see that.
Right. That's what that's what I take with a lot of these experiments. That's why we're like, people. Some of people have commented on the lack of data acquisition and all that stuff. We're not that even at that stage yet. We're just trying to do a POC, proof of concept. And
We do have a lot of data acquisition equipment. Actually, it's all up in one of these boxes over here. But there's not every single experiment even needs that. Like we were working earlier with a pendulum system. You really don't need data acquisition to see that it's turning. The data acquisition is the camera, which in most cases is the best form of data acquisition. The only you need data acquisition is when it's not flying, when it's not creating a movement. That's when you need data acquisition cards, or you want to make sure that there's no ionic leakage. Then there's other ways of doing that. Like we have the smoke stick method, the incense stick. You burn an incense stick near a high voltage device. You want to make sure that there is no ionic leakage, creating an ion wind effect. You just let that smoke pass up next to it, and if it's moving in the opposite direction of its travel, you know that you're dealing with ion wind. And there's a lot of methods that don't require any equipment, and these experiments, many of them can be replicated on the cheap, and real easy to do at home.
Well, I can say this much about data acquisition. As the Caltech in-house, we are looking for proof of concept, as Jeremy just said. We're not trying to get good data because we don't have any data. Why take data on a system that produces 0 volts and 0 amps? The point is that we want to see if it's producing something first. So instead of looking for it with numbers on a display, we're looking for it in physical motion on a torsion pendulum, which there's absolutely nothing wrong with if you're simply looking to see if something is either a motion or a lack of motion. Now, if we get any results, then we're going to go on to the point of taking measurements of those results and trying to figure out exactly what our power input versus our power output is, where possible contributions of error are, and what we can do to improve the design if it does indeed work. But at this point, on our Sunday off, we're just basically testing this stuff. That's it. We're checking it in a very, very simple yes and no manner. It works or it doesn't.
right. And yeah, that's I think it's a very simple way of putting it, man. It's like either it works or it doesn't. We're just setting up the experiments, trying to calibrate them. We to get Jeremiah, he's an expert in calibration. We have a team of us who constantly argue, and no one's in agreement. If you're all in agreement, you're not going to get anywhere. You're in an echo chamber, and you're not gonna figure out who's right. You're gonna think you're right, and you're gonna be wrong and stuck in your own delusion, and you're gonna simulate a reality based on that delusion, which is going to come to a catastrophic end at some point when you realize it is a delusion. Like most realities, all theories kind of like have this life in science. They live to a certain point until we find out, it's like Newton's Principia, the theories that he laid down with were basically like proven to just be like the classical case. It's a much more complex model, and this is just like the classical version of it at very it's just physics at very normal speeds and normal sizes, but the physics at really high energy and really high speeds and really small scales is much different. It's not like just the realm of classical physics. It's just a small case of a much bigger theoretical understanding of the universe. So, whenever you guys want to run it.
Carl Christopherson said this is how you should start your live streams. I actually very much agree with that. We need to start with just a round table discussion with everyone sitting down and calm and level-headed and the microphone's working. We were in a bit of a rush today to get it going.
Yeah, that was bad, man. I was just trying to get it going, and I looked at the clock. I'm like, my God, it is 6:40. I had it working at 6 o'clock with my method, and Mark insisted that we get a third microphone hooked up. and I knew that would cause problems. And we used an old piece of mixing board audio equipment that was the only thing he had to try and get the 3 microphones on a mix instead of 2, and it just caused utter fucking chaos. And I was just like, fuck it, we need to go live, and I'm doing it now, like, you know. So I don't know, and it didn't work out, and then I.
We're just about ready to explode the wire here. We'll go out with a bang.
Let's go out with a bang, and then we're gonna wrap this live stream up for tonight, and we're gonna work on getting some more experiments and getting some serious shit on the show for tomorrow, man. I know it's sad, man, that this is Trump's Space Force, but you know we're working with limited resources here. So if you guys can help, please. I appreciate everyone who contributed tonight. The $20 live from Carl, and another $20. So Carl did $120 tonight. Man, this is how you start a live. Context. Yes, I know. We had a whole plan. I had a whole plan for how to start this and everything, and it just went to shit tonight. I don't know. The planets were aligned a couple days ago, and I had massive inspiration, and I got a lot of stuff done, but. Now that the planets are falling out of alignment, I think hopefully we can stay on this course and this trajectory.
Should be behind you, I think.
All right, we're gonna blow some shit up.
I'm on him. Alright, this may or may not. Fire extinguisher ready. Not that we'll need it. That's a CO2, which is really, really nice because CO2 extinguishers won't damage your equipment if you have to use them. Stand by. Alright. We are now charging.
Read out the voltage.
Coming up. 10 kV. 15 kV. 20. 25. Beware if a false snap happens. It could go at any time. These capacitors are unknown. We have not charged them to the potential we're about to charge them to.
What are you taking them up to?
We see no leakage current, which is good. We're going to take them up to close to their potential, roughly about 40 kV. 28, approaching 30. I hear leakage. 32.5 kV. This is probably sufficient to blow the wire. At this point. Alright. I'm going to leave the high voltage power active. I have it set on the overload setting, so when we trip the power supply, it should shut off. This wire is likely to become vapor.
Jeremy, we're going.
Yep, I'm ducking. There you go. No, it just blew the end. Alright, we can go up to a slightly higher voltage. It did vaporize the end of that wire pretty nicely, but not enough impulse energy to completely vaporize it.
Sweet.
Wire is cold, which is not surprising.
Is there any potential across the capacitor now?
I would certainly assume that there is. And I am going to short this system out. Not quite as much impulse energy as I was hoping for. There. No, we definitely do not have any energy in those capacitors. Should we take them up to 45 kV and see what they do?
As long as we don't get any explosions.
Well, I can't guarantee that because, again, we haven't tested them at their full rated voltage.
Well, I guess if you go at 45 kV, we'll never know.
That is true.
What was that before?
What did we go up to? 30 something? It's in the video log. Oh, let's see. We need our spool of wire.
Right here.
Thank you.
Totally advertising for Home Depot, man, with these buckets and this husky.
Yeah, Home Depot is the official anti-gravity hardware store.
Yeah, sponsorship free for now. Where is that sponsorship from Home Depot? Funding the secret underground garage
They
door.
might as well be giving us some friggin'.
Yeah, we haven't gotten any promotions.
Some anti-gravity supplies.
All those freebies, we don't have any of those.
Well, what about the dollar store? Like, shout out to the dollar store. They've done a swell job getting us lots of
I
equipment.
do like the term, the dollar store, completely generic, could be literally any dollar store in the
Oh,
world. but
the
you know what?
camera just shut off. It ran out of battery, I think.
Yeah.
Eh.
It's alright. I got let's see.
Let me see if I can turn it back on again. Oh, it's going again.
Hold up. I have the power supply for it.
Let me get the power strip. Yeah, that's the right one. Okay. Oh, battery level low. Let's change battery. It says. Okay, we should have that camera live again. See if it's popping up.
Turn this transformer up. See if that works for now. Let me just get this tape.
Beam me up, Scott. Yeah, that's correct. We're basically testing the capacitors right now. So this is a capacitor test, and we're going to charge it up to the full 45,000 volts. Okay, Mark, are you reading the chat? Solar Marshal, yes, I am. What about the aliens in the water for hydrogen? That makes absolutely no sense. So there's tons of hydrogen in the solar winds. They wouldn't have to come to Earth.
Why do USOs? So this is the question. Why do so many USOs go into the water? Like there's so many like water. There's so many UFOs going into the water. USOs. There's so many like. Why are they so attracted to water? Why? What scientific reason or explanation could be for that behavior of them going into the water, in and out? What do you think? I'll tell you what I think.
Well, I think any USO or unidentified submerged object that's going into the water is the same is here for the same reason that they're abducting humans and doing these animal mutilations, because anti-gravity and these interstellar travel devices are nothing compared to how complex biology is. Biology is by far the hardest section of science. It really is a complete understanding. You have to have a complete understanding of the physics, the biology, and the chemistry in order to end up with a biological system and DNA.
The physics is the core. First is mathematics, then if you get the pure mathematics, then you start being able to understand physics from there. And then physics builds into this whole world of chemistry. And then with chemistry, you can build molecules, and then you can build pretty much fucking anything with organic molecules once you get into organic chemistry. And then it's pretty much it's the sky's the limit with these proteins and life and all that stuff. So it gets infinitely complex. There's infinite layers of complexity going down on that scale. So yes.
Yeah, by far biology is the most complex area of science. Solar Marshal asked again. You stated that UFOs going into the water. You stated that they were getting hydrogen from the water. No, that's incorrect. I probably misspoke or something like that. But if any extraterrestrial wanted hydrogen, they'd be able to get that from the solar wind. There's lots of hydrogen out in the solar system. They can pick it up from a star, which is mostly hydrogen as well.
It would be much easier to extract hydrogen from like water. I think water is the best source of it, or deuterium even. And what if it's deuterium or like because there's a small amount of deuterium inside of water. Well, it's deuterium is heavy hydrogen, so it's like basically like if what I think their reason is that they're trying to is that they need water for fuel. They're doing some kind of cold fusion because cold fusion would literally turn all of our world's oceans into bottomless fuel tanks. Like the amount of deuterium in a cup of seawater can power New York City for like I think it's like a couple days. So we could basically power of a gallon of it would power. I forget the calculations for all this. I have it somewhere. I mean, this is really bad, really bad on the spot. But I don't want to be wrong and say something wrong, so I'm not going to say it. But yeah, basically, like I think that the UFOs are going in the water for cold fusion, and that they're doing something with the water and the hydrogen. They're stripping the hydrogen off, and because it's much easier to get water from hydrogen from water than it is to get it from a star, or just to collect it trying to float around in space. It's a much more dense, and I think they're attracted to these kind of places in general. I think our planet's pretty much like a refueling stop for them.
Oh, he also mentioned helium-3 on the moon. Yeah, that's all theoretical because it hasn't been really studied that well whether fusion would work with helium-3. One of the interesting things that I don't see happening with the whole fusion community is getting rid of the whole tokamak design, the donut shaped, and just going with a sphere. Like, why would you fight nature and go with this donut shaped device? Fusion happens naturally in nature in the form of a ball, namely the sun. Why are you trying to make a star into a donut? Like, it really doesn't make any sense. And they're pouring tons of money into these tokamak designs when they could just do a ball shape and probably have much better results.
Well, Mark, I think the reason for the the reason that it's a torus instead of a bowl shape or a sphere is because of the topology, I thought, right? Because a torus has a hole in it. It's a different topology than a sphere. For example,
More surface area, though. It's harder to keep it hot.
it's not about that, okay? The issue is the topology. So put it like this way: if you had a billiard ball and the billiard ball was hairy and had hairs all over it, would you ever be able to comb it? No, because there'd always be one spot that you'd have to start and one point where it would end. You could never comb it, no matter which direction or how you comb the billiard ball. You could never get all the hairs to ever be fully combed. You know what I mean? But if you did it with a torus, you could just wrap them around the inside, and all the hairs would be combed, and everything would be combed, and all the hairs would line up. But you can't do that with a billiard ball.
Right, but all you need is pressure and heat to make fusion.
So the only way you can do it with a billiard ball is to be able to understand the mathematical magnetic vortexes and the way that monopoles through some kind of, there's got to be a geometric way to do it. You know what I mean?
A ball.
I bet you there's a way to do it with a ball, right? But that's what I'm saying is I just think I may have tipped somebody off on it. If we come up with a geometric way of the mathematics of how you'd have to set up a ball reactor to get it, but then you have to have that's the Poincare, isn't that the Poincare conjecture or something? What's the hairy billiard ball thing? I gotta look that up. Let me go look that up real quick.
I'm not sure, but the problem with
Enough theoretical physics.
the problem with fusion reactors is that it's very difficult to keep them going because you need high pressure and high temperature just to keep the reactor going. And then once you have the reactor going, you're able to siphon off a little bit of that energy to use toward energy production using regular boiler systems, steam systems that turn turbines. The issue has always been that with the tokamak, it's the insulation problem because you need to bring these up to the hydrogen up to a very high temperature in order to get the reaction. So the insulation has been a major problem. They're using these magnetic fields to keep the plasma concentrated in one place and far away from the edges, and using vacuums and stuff to keep it far away. But still, we're dealing with such high temperatures that it's literally radiating heat toward the sides, and they're using these high temperature like shielding materials. And I think because of the torus shape, there's such high surface area that they're just losing tons of heat that way, and they're unable to maintain the effect. Going with a ball would be much better. It would be a another challenge because they'd have to figure out how to maintain the plasma in the center without the ability to have so much space. Like a torus offers you a lot of space around the field where you can put all your electromagnets. With a ball, all you have is the ball. It's like minimal surface area, so you got to figure out a way to get all the electromagnet coils, your receiving heat, the heat that you're putting into it. All of that needs to come in from a minimal surface area. That's one of the main issues.
That's the delayed one. You have to go. Let me go down here and put it on live. So you just look it on here and you'll be able to see it live. You can read the live chat or.
I don't think we're. I think we're looking from the webcam now.
But anyways, yeah.
Are we ready?
Are we ready? Are we doing it?
Yeah, we can run it.
I liked it when you were over there and I could do it with the two cams like I had it set up. You want to narrate? Because I'd like to leave the mic over here with you. If you could narrate, tell what's going on. Well, just you can put it right here so you can do it.
Well, I'm not going to leave it on top of this because this is going to vibrate with 60 hertz, and it's going to be very, very loud for the mic, so you guys can hear. I'll just tell you what voltage we're at and what we're about to do. So we're going to give these caps a full voltage test. We're going to take them up to their 45 kV rated maximum, and we're going to hope that their polypropylene dielectric and oil-filled systems do not blow through and possibly blow up. Alright folks, we're approaching 12.5 kV, bringing up on 15, 20. The system is now crackling. We have ionic leakage, approaching 25, coming up on 30, 35 kilovolts. We're coming up on 40. And here we go. We're going to take it right to 45 kilovolts. We have our power supply set on overload, so when we short it out, the power supply will trip itself out and wait for a reset, so it won't continuously draw current. And now we are going to connect this wire and see if we have enough stored energy in these capacitors to blow through it. So here we go.
Wait a second. Let me get in focus.
Yeah, go ahead. A nice PVC 4-foot long stick is going to keep me safe from this, but not from the sparks, if there are any. Ready? 5, 4, 3, 2, 1. And it did not blow the wire. But our capacitors do maintain their full rated voltage of 45 kV. Oh, did you really? Well, here we go. Stand by. Charging.
You don't have a wire on it.
No, the wire is still there. It didn't blow it, but strangely, we seem to be charging almost instantly, which is a little weird. Our ground is connected on that side, yes.
Yep.
Our voltage is connected on this side. The cap's charged almost instantly.
I need to put something behind it.
Alright, we're going to try this again.
Can you wait a second? Is that charged?
Yes, extremely. Stay away from it. We're just going to hit it again. 5, 4, 3, 2, 1.
Wire broke this time.
That was a decent snap. These caps don't have quite as much energy as we'd like, but they do seem to be working alright. I am surprised at just how fast they charge up. I guess that supply has quite a bit of current output, more than sufficient to charge these quickly. But you do have those paper caps. So did I. I guess I can say I'm a little disappointed by those caps. But still, for a fast impulse experiment, it may be sufficient. You do have the paper discharge caps too. And we're set up to test them if you want to try.
I'm dead tired. I just want to hit the sack.
I think that deserves another beer.
I certainly wouldn't say no.
Oh, what do you say, people, huh? What do you think?
Good way to end the Sunday, because on Monday we've got to get down to taking the data. We've got to get down to setting these experiments up to actually record the information that we can derive from them and figure out if there are any very small forces, regardless of how insignificant they may be.
That is correct.
All right, guys. We're going to... the donation page. I don't know. We can. I'd like to. We'd like to get like a bunch of stuff together from like, Home Depot gift cards and what other? What do we need?
We need a slow motion camera.
We need a slow-mo camera. That's what Mark is obsessed with lately. He wants a slow motion camera so we can do that experiment, and we can do a whole. We have all this cool equipment. We can do a whole bunch of experiments, but it would be even cooler if we could do those in slow motion. So we got to either find someone who has a slow motion camera that wants to work with us to do a whole bunch of experiments and film them, or we need to rent one and do a whole bunch of really cool experiments with a slow motion camera. But that's more of like a individual, like each individual slow motion video that will get like 2 million views. That will really blow up this channel if we get a slow motion camera. But yeah, that's on the list of things to do. We also I'm gonna do some short. My real goal at this point is to hire a good video editor and someone who's really good at production. I'm getting Adobe Photoshop and Adobe Premiere, and I'm getting Final Cut for the Mac as well, and we're going to try to start editing down some of this. We're going to start trying to do some of these experiments, make some really good quality videos, and edit them down so that we can really quickly and efficiently explain all this really complex science to retards like us and myself, because I'm really fucking stupid. And as someone said, we're just a bunch of monkeys smoking weed and trying, and drinking vodka and trying to, and figure out, and beer. And, right, that's all these people are, and we're a perfect representation of humanity, because that's, that's what most of us are, sadly. We're trying to break us out of that, and I'd like to, even though we're starting now in our alcoholic phase, this is eventually going to sober out. And we're going to grow up and get sober and and get serious about. We're already sober and serious about this. I mean, come on, dude. I've been doing this for 16 years. We're just having a little fun on a Sunday. So lighten up with the drinking stuff. It's not something to focus on, people. It's kind of I don't know. We also maybe should cut it out on the next live stream. We'll not make it a theme, but I don't know. It's still at the same time. Zephram fucking Cochrane discovers. He's a pop culture icon that discovers anti-gravity in pop culture, and he drank friggin' beer and he cursed the whole damn time and was like basically an anti-gravity pirate to create the world's first warp drive. So, I don't know. I don't know what you have to say about that. Let me find the other. Where's the other camera now? No.
Well, whatever you guys are going to do. Michael, I think I'm going to cast an epoxy Litharge mix before I decide to head on out of here, so we can have a sample ready tomorrow. The wax is great, but I think epoxy might be very nice since we haven't tested that mixture yet. It's not baked light, but it's close.
Very cool. Yeah, we're gonna get some rest, and we got some real experiments to do tomorrow. So thank you all for watching and being part of this, and just be glad that we open this up completely wide open, just to show you shit's real, and we're not you know, these fakers trying to pretend to be something we're not. All right, that's all it's about. Just be real with yourself, be real with the world, be real with who we are, and the world will be real with you. So thank you all for watching, and let's do this together, science for humanity, and let's start getting sober and clear-headed about this on the flip side, in the shortened down, edited versions of all this.